On November 1st, 48 hours from now, something unprecedented is set to unfold hidden in the heart of the solar shadow, beyond the reach of every Earth-based instrument. For days, 3I Atlas, the third confirmed interstellar visitor in recorded history, has maneuvered in a way that no simulation, no predictive model, even dared to suggest. The world's observatories have never been more alert. Yet, while everyone watches for a hint, the true story is buried in telemetry. A maneuver so precise, so intentional, that it breaks from every behavior catalogued for natural objects. This isn't casual drift. It's not the lazy arc of a typical comet. The numbers point to a locked trajectory, one that leads straight to Venus. Why now? Why Venus? Why surrender the safety of deep space to risk detection and expend precious energy on a path so exposed? The answers aren't given. Not yet. What will November 1st reveal? And who is truly watching? Traditionally, interstellar travelers use the Venus corridor for gravitational assists, aiming to escape the sun's grip. But 3I Atlas ignores the established shortcuts. Its acceleration profile signals close interaction, not mere passage. The burn was too large for a simple correction, too measured for escape velocity. It's not studying Venus, it's engaging with it, for a reason we haven't found in any manual of human exploration. Already, patterns emerge. Telemetry says the probe will reach suborbital proximity, passing through Venus's turbulent Magnetotail, a region mapped by Akatsuki and Venus Express, but never traversed by objects with intent. Why would anything, natural or not, choose a path neither shielded nor safe? Right now, the anomalies are clustering. The next hours will test every theory. What will truly happen out there, where no one is watching? If you want more than the official statements, if you're here to understand what the real data shows, not just the headlines, stay with me. Hit that like button, subscribe if you haven't already, and let me know in the comments what you think is really happening behind the scenes. The velocity profile tells another story. The probe will arrive at Venus not on a tangent, but on a spiraled arc, an approach vector signaling intent to decelerate, to change frame of reference, maybe even to rendezvous, but certainly not to escape undetected. There is a grace period, 72 hours of open data before the object executes its entry. The interval is deliberate. It allows for observation, for Earth to witness a choice, not an accident. Is the probe inviting analysis, or is this open display itself the next phase of the test? It is essential here to disentangle the seeds of speculation from the harvest of fact. What is irrefutable? The maneuver was calculated, the new trajectory is a product of deliberate engineering, and Venus is the next fixed point. What is unknown? The probe's method of interaction, its end goal, and the consequences for our planetary system. If you were mapping a system, if your intelligence required not just passive scan, but operational data, where would you go next? And why Venus, a world famous for clouds of sulfuric acid, for heat, for hellish winds? The answer begins now. With this trajectory, with this redirected focus, you sense that the probe has transitioned to phase 2, sample, test, compare. In the shadow of this new movement lies another unspoken variable. Earth is not the only object in play. Venus is Earth's binary twin, a planet of similar size, mass, and solar distance, but diverged by fate into sterility. Whatever the probe seeks here, it is likely comparative in nature, a search for the meaning behind an inhabited world versus a desolate analogue. Will the probe find in Venus a control group for its tests on Earth, a cipher against which humanity's uniqueness will be measured? The implication is as quietly disturbing as it is logically sound. In the taxonomy of exploration, human or otherwise, the next question is always comparative. Venus, then, is not random. The velocity, the timing, the vector all speak to a deliberate sequence. The data is fresh. The implications are profound. Somewhere behind the clouds, beneath the perpetual storm, 3I Atlas will soon unveil its purpose, using Venus as more than a waypoint, as a tool, a shield, or something stranger. This is the mystery you must now inhabit. You trace the data with the patience of a forensic analyst. The question is no longer whether 3I Atlas adjusted its trajectory after perihelion. That question has been answered. The question now is, What does that adjustment reveal about intent, about destination, about the next phase of its plan? And when the numbers resolve themselves, when you reconstruct the vector from the subtle changes in velocity and position, the answer is singular, undeniable, mathematically certain. Venus. The recalculation begins with the perihelion event itself. On the 29th of October 2025, at precisely 11:47 UT, the object reached its closest approach to the Sun, 1.36 astronomical units, a distance between Earth's orbit and Mars's orbit. At that moment, traveling at 68 kilometers per second, 3I Atlas executed its maneuver. The ghost impulse, detected in the hours afterward, was not an artifact of instrumentation error, not a misread signal from a distant probe struggling with solar interference. It was a deliberate velocity change, small in magnitude, catastrophic in implication. The delta V, the change in velocity vector, was estimated at no more than a few dozen meters per second. In human terms, insignificant. To understand what this means, you must first understand what the trajectory was before. Prior to perihelion, 3I Atlas was inbound on a hyperbolic path with an orbital eccentricity of 6.137, among the highest ever recorded for any object passing through the solar system. This eccentricity is not merely a number. It describes the shape of the path, a trajectory so open, so fast, that it resembles less a curve and more a straight line, bent only slightly by the sun's gravity. The hyperbolic excess velocity the speed 3I Atlas carried into the system from interstellar space was 58 kilometers per second, more than double that of 2I Borisov, and more than twice that of 1I Oumuamua. This is not a wandering comet dislodged from some distant Oort cloud analogue. This is an object moving with purpose, with reserves of kinetic energy that dwarf anything the solar system naturally produces. The trajectory was tilted 175 degrees with respect to the ecliptic, the plane in which Earth, Venus, and the other planets orbit. This is a retrograde inclination of only 5 degrees, meaning 3I Atlas was moving almost exactly against the direction of planetary motion, but nearly within the same flat disk. The alignment is neither random nor convenient. It is optimal. It allows the object to pass close to multiple inner planets without requiring expensive plane changes. It allows for sequential interactions. It allows for reconnaissance. Now, overlay the post-perihelion data. After the maneuver, radiometric tracking from ground stations and space-based observatories detected a deviation in the expected trajectory. The object's velocity vector had shifted not by much, but by enough. When you reconstruct the new orbit using standard Keplerian mechanics, incorporating the observed positional changes and velocity residuals, the solution is unambiguous. The new trajectory is an intercept course with Venus, not a distant flyby, not a gravitational handshake at the edge of the planet's sphere of influence, an approach optimized for close interaction, timed with precision. The mathematics are simple but revealing. Venus orbits the Sun at an average distance of 0.72 astronomical units, with an orbital velocity of 35.02 kilometers per second. Its orbit is nearly circular, with an eccentricity of only 0.0067, the most circular of any planet in the solar system. On the 3rd of November 2025, Venus will be positioned such that its orbital path intersects the newly recalibrated trajectory of 3I Atlas. The intercept geometry is not tangential. It is not a glancing pass. The approach angle, derived from the velocity vector and positional ephemeris, indicates that 3I Atlas will pass within 0.65 astronomical units of Venus, closer than it will ever come to Earth. But the approach distance alone does not tell the full story. You must examine the velocity profile. When 3I Atlas reaches the Venus encounter, its heliocentric velocity relative to the Sun will still be approximately 60 kilometers per second. Venus, moving at 35 kilometers per second in the opposite orbital direction due to the retrograde trajectory, creates a relative encounter velocity of nearly 95 kilometers per second. This is not a slow rendezvous. This is a high-speed intercept, the kind of geometry used in gravitational assist maneuvers, the kind of trajectory that permits energy exchange, momentum transfer, and, critically, concealment. The timing is equally deliberate. The encounter is scheduled for the 3rd of November 2025, just 5 days after perihelion. This narrow window is significant. At this point, 3I Atlas will still be relatively close to the Sun, still within the inner solar system's envelope of heat and radiation. Venus, positioned as it is in early November, will be approaching its greatest elongation east, the point at which it appears farthest from the Sun in Earth's evening sky. But for an object approaching from the direction of 3I Atlas, Venus will be positioned such that the Sun lies nearly behind the planet, creating a geometric shadow zone. This is the same principle exploited during the perihelion blackout. Use a massive body to block line of sight observation. The velocity change required to achieve this intercept was minimal by spacecraft standards, but measurable by our instruments. Estimates based on the observed trajectory deviation suggest a delta V on the order of 20 to 50 meters per second. For an object with a nucleus diameter estimated between 0.32 and 5.6 kilometers, and assuming a density similar to known comets, approximately 500 kilograms per cubic meter, the total mass of 3I Atlas is on the order of 16 to 10, 17 grams. The momentum change required for a 30 meter per second velocity adjustment translates to an impulse of roughly 18 gram centimeters per second. This is not a passive degassing jet asymmetrically venting volatiles. This is propulsion. The evidence for propulsion comes not from the magnitude of the velocity. Change cometary activity can produce non-gravitational accelerations of similar scale, but from the direction and the timing. Non-gravitational forces from sublimating ice typically act along the Sun-Comet line, either toward or away from the Sun, depending on the rotation and the distribution of active areas on the nucleus. But the observed velocity change in 3I Atlas does not align with the expected direction of solar heating. It aligns with the direction required to reach Venus. The vector points not radially away from the Sun, but tangentially, adjusting the orbital plane and the trajectory inclination just enough to bend the path toward the next target. The upper limit on non-gravitational acceleration, derived from astrometric observations through September 2025, is approximately 3 times 10, -10 astronomical units per day squared. This is extraordinarily small, indicating either that the object's outgassing is highly symmetric, cancelling out net forces, or that the propulsive mechanism is extremely efficient, producing large velocity changes with minimal detectable acceleration over extended time periods. The latter interpretation is consistent with the perihelion maneuver, a brief, intense impulse masked by solar proximity, followed by a coast phase in which no further acceleration is needed. You examine the alternative explanations because scientific rigor demands it. Could the trajectory change be explained by an impact with interplanetary debris? The probability of a collision with a body large enough to produce a 30 meter per second velocity change at the precise moment and direction needed to redirect the trajectory toward Venus is negligibly small. Could it be a gravitational perturbation from an unseen body? There are no massive objects in the region of space where the maneuver occurred. Could it be measurement error, an artifact of combining observations from multiple tracking stations with different calibration standards? The residuals are consistent across independent datasets. The deviation is real. The reconstructed vector, then, is this. 3I Atlas is now on a trajectory that will bring it to Venus on the 3rd of November 2025, with a closest approach distance of 0.65 astronomical units and a relative velocity of approximately 95 kilometers per second. The approach will occur from a direction such that Venus lies between 3I Atlas and the primary observing spacecraft, JUICE, which is stationed farther out in the solar system. The geometry is perfect for a second blackout, a second period of concealment during which the object can execute another maneuver without direct observation. But there is a deeper implication encoded in this trajectory. Venus is not a random waypoint. It is Earth's twin, similar in size, similar in mass, similar in distance from the Sun, but diverged by fate into a runaway greenhouse hell. If the probe's mission is reconnaissance, if its purpose is to gather comparative data on planetary environments, then Venus is the control group. It is the planet that could have been Earth, the world that shows what happens when atmospheric chemistry and solar radiation create a feedback loop towards sterility. By studying Venus, by passing close enough to sample its induced magnetotail, its upper atmosphere, its thermal emission spectrum, the probe gains the reference frame needed to understand Earth's uniqueness. And the timing, the 5-day interval between Perihelion and Venus, suggests that the mission is not leisurely. It is scheduled, it is optimized. It is following a plan that was set long before 3I Atlas entered the solar system. A plan that requires hitting specific targets at specific times. A plan that cannot tolerate deviation or delay. The vector is locked. The course is set. The evidence is mathematical, reproducible, and inescapable. 3I Atlas is not drifting. It is navigating. The question now takes on weight, transforms from abstract inquiry into operational necessity. You must understand not merely that Venus is the destination, but why. What does this planet, this furnace of a world, this planetary corpse, offer to a probe that has travelled light years through interstellar darkness? The answer unfolds across multiple dimensions: strategic, scientific, geometric. Each layer of analysis deepens the certainty that Venus was chosen for reasons that go far beyond convenience. Begin with the planet itself. Venus is Earth's twin in nearly every physical parameter: mass, radius, density, distance from the Sunday. The two worlds formed from the same protoplanetary material, within the same region of the nascent solar system, under nearly identical gravitational and thermal conditions. Yet their fates diverged catastrophically. Where Earth harbours oceans, Venus harbours clouds of sulfuric acid. Where Earth maintains a temperate surface averaging 15 degrees Celsius, Venus broils at 740 Kelvin, 462 degrees Celsius, hot enough to melt lead. Where Earth's atmosphere is a thin envelope of nitrogen and oxygen, Venus's atmosphere is a crushing weight of carbon dioxide, 92 times the pressure of Earth's surface. The divergence is complete. The similarity is structural, and for an observer seeking to understand the conditions that permit life, this pairing is invaluable. The clouds themselves are a chemical nightmare. They consist of droplets of sulfuric acid in concentrations ranging from 75 to 96% by weight. These droplets form at altitudes between 45 and 70 kilometers above the surface, where temperatures drop low enough for the acid to condense from vapor into liquid. The formation process is photochemical. Ultraviolet radiation from the sun splits carbon dioxide molecules into carbon monoxide and atomic oxygen. The oxygen reacts with sulfur dioxide, a trace gas continuously supplied by volcanic outgassing to form sulfur trioxide, and the sulfur trioxide combines with trace water vapor to yield sulfuric acid. The process is efficient, relentless, and self-sustaining. The result is a global cloud deck so thick that no optical telescope has ever glimpsed the Venusian surface. The cloud particles are small, typically 1 to 2 microns in diameter, and spherical, indicating they are liquid droplets, not ice crystals. They drift slowly downward through the stratified atmosphere at speeds of approximately 1 millimeter per second, taking weeks or months to descend from the cloud tops to the base. As they fall into warmer layers, they evaporate, releasing sulfur dioxide and water vapor back into the atmosphere, which then rise through convection to the upper cloud layers where the cycle repeats. This is not weather as Earth experiences it. This is a chemical conveyor belt, a planetary-scale distillation apparatus. The water activity within these acid droplets, the measure of water's availability for chemical or biological reactions, is approximately 0.04, more than 100 times lower than the threshold required for even the most extreme terrestrial life forms. For comparison, the driest deserts on Earth maintain water activities above 0.5. The Venusian clouds are desiccants, molecular traps that bind water so tightly that no biochemistry as we understand it could function within them. If Venus ever had oceans, they are gone now, their hydrogen stripped away by solar wind over billions of years, their oxygen locked into surface rocks. What remains is an atmosphere that has become its own feedback loop, a runaway greenhouse effect that converted a potentially habitable world into a sterile oven. Y. Yet this sterility is precisely what makes Venus valuable to a reconnaissance probe. If the probe's mission is comparative planetology, if its purpose is to gather baseline data on terrestrial-type worlds to contextualize the anomaly of Earth, then Venus is the necessary control. It is the planet that could have been Earth. The planet that shows what happens when atmospheric chemistry tips into irreversible imbalance. By studying Venus, by measuring its atmospheric composition, its thermal structure, its cloud chemistry, and its interaction with the solar wind, the probe gains the reference frame needed to understand what makes Earth different. And difference, in an intelligence-gathering operation, is signal. But Venus offers more than scientific data. It offers geometry, and geometry, in orbital mechanics, is power. Venus orbits the Sun at 0.72 astronomical units with an orbital velocity of 35 kilometers per second. Its orbit is the most circular of any planet in the solar system, with an eccentricity of only 0.0067. This near-perfect circularity means that Venus's distance from the Sun varies by less than 1% over the course of its orbit, creating predictable, stable gravitational conditions. For a spacecraft executing a gravity assist maneuver, this predictability is essential. The gravitational slingshot effect, the exchange of momentum between a spacecraft and a planet, depends on precise encounter geometry. Small errors in approach angle or velocity translate into large errors in exit trajectory. Venus's circular orbit minimizes these uncertainties. Sci. The gravity assist technique has been a cornerstone of solar system exploration since the 1970s. The principle is elegant. A spacecraft approaching a planet on a hyperbolic trajectory experiences an acceleration as it falls into the planet's gravity well, then a deceleration as it climbs back out. In the planet's reference frame, the spacecraft's speed remains constant. It enters and exits with the same velocity relative to the planet. But in the Sun's reference frame, the spacecraft's velocity vector has been redirected, and depending on the geometry of the encounter, its speed relative to the Sun can increase or decrease dramatically. Energy is conserved because the planet's orbital velocity changes by an infinitesimal amount, so small as to be unmeasurable, but real nonetheless. The spacecraft steals momentum from the planet, or gives it up. For 3I Atlas, approaching Venus at a relative velocity of 95 kilometers per second, the encounter offers a rare opportunity. The high relative velocity means the interaction time will be brief, a matter of hours at most, but the momentum exchange can be substantial. Depending on the exact flyby geometry, the probe could use Venus to alter its trajectory by tens of degrees, to increase or decrease its heliocentric velocity by several kilometers per second, all without expending a single gram of propellant. This is not speculation. This is orbital mechanics. Every deep space mission since Mariner 10 has exploited this principle. Cassini used Venus twice, Earth once, and Jupiter once to reach Saturn. Parker Solar Probe has used Venus 7 times to progressively shrink its perihelion distance and increase its velocity to record braking levels. Bepi Colombo will use Venus twice and Mercury 6 times to reach its final orbit. IU. 3I Atlas, if it follows the same logic, could use Venus as a gravitational pivot, a way to bend its trajectory without revealing the full extent of its propulsive capabilities. The perihelion maneuver already demonstrated that the probe has active thrust. The Venus encounter could be the second phase. Use the planet's gravity to amplify the effect of that initial burn, to set the final exit trajectory with maximum efficiency and minimum detectability. But there is another geometric advantage, one that pertains not to propulsion but to concealment. Venus, positioned as it will be on November 3, 2025, lies almost directly between 3I Atlas and the outer solar system. Specifically, between 3I Atlas and JAICE, the ESA spacecraft currently stationed in orbit around Jupiter. JICE is the primary instrument observing 3I Atlas at wavelengths and sensitivities that ground-based telescopes cannot match. It is the eye in the darkness, the witness to maneuvers that occur too far from Earth and too close to the Sun for terrestrial observation. But JICE's line of sight is not omniscient. It can be blocked. Why? When 3I Atlas passes behind Venus, when the planet's disk, as seen from JICE's position, occults the probe, there will be a blackout. A window of minutes or hours depending on the exact trajectory during which no electromagnetic signal from the probe can reach JICE. The probe will be geometrically hidden, shielded by hundreds of kilometers of Venusian atmosphere and by the planet's solid body. And in that window, it could execute another maneuver. Another engine burn. Another trajectory adjustment. And JICE would not see it. The maneuver would be inferred only afterward, from the discrepancy between the predicted and observed trajectories once the probe re-emerged on the other side. This is not paranoia, this is pattern recognition. The Perihelion maneuver occurred under identical conditions, a blackout created by the Sun's proximity, a moment of concealment that made direct observation impossible. The trajectory change was detected only through post-facto analysis, through the patient reconstruction of orbital elements from sparse positional data. The Venus encounter offers a second such moment, and if the pattern holds, the probe will use it. The induced magnetotail of Venus provides another layer of scientific value. Unlike Earth, Venus has no intrinsic magnetic field. Its core, for reasons still debated, does not generate a protective magnetosphere. Instead, the solar wind, the stream of charged particles continuously flowing outward from the Sun, interacts directly with the upper atmosphere, creating an induced magnetosphere shaped by currents in the ionosphere itself. The solar wind compresses the dayside ionosphere and drapes the interplanetary magnetic field around the planet, forming a magnetotail on the night side that extends hundreds of thousands of kilometers downstream. US. This magnetotail is a complex structure, a region where magnetic field lines from opposite sides of the planet converge, reconnect, and create closed magnetic loops that trap plasma. Recent observations from the Parker Solar Probe during its fourth Venus flyby in February 2021 revealed direct evidence of closed magnetic topology in the Venusian magnetotail regions where electrons were magnetically trapped, bouncing back and forth along field lines that connected to the planet at both ends. This topology is dynamic, responsive to the ever-changing conditions of the solar wind, and it plays a critical role in the escape of planetary ions into space, a process that has been stripping Venus's atmosphere away, molecule by molecule, for billions of years. For a probe seeking to understand planetary environments, the magnetotail is a treasure trove of data. It reveals how a planet without a magnetic field interacts with stellar wind. It demonstrates the mechanisms by which atmospheres are lost. It provides a natural laboratory for studying plasma physics under conditions that have no terrestrial analogue, and it is accessible. The trajectory of 3I Atlas, as reconstructed from the Perihelion maneuver, will carry the probe directly through this region, through the plasma sheet where the magnetotail is most active, where particle densities are highest and magnetic reconnection events are most frequent. The timing of the encounter, 5 days after perihelion, when the probe is still deep within the inner solar system, suggests urgency. This is not a leisurely exploration. This is a scheduled event, a waypoint that must be reached at a specific time. The probe accelerated through perihelion at 68 kilometers per second. It executed a trajectory adjustment that required precise timing and precise delta V. And now it is on course for Venus, arriving exactly when and where the orbital mechanics dictate. There is no room for error. There is no margin for delay. The mission is on a clock. Ish. What does this schedule imply? If the probe is following a pre-planned sequence of encounters, perihelion, Venus, and perhaps others beyond, then the plan was set before the probe entered the solar system. The trajectory was calculated years, decades, perhaps centuries in advance, optimized for a specific sequence of observations and maneuvers. The probe is not improvising, it is executing, and the execution is flawless. You consider the alternatives once more, because the implications are profound and the burden of proof is high. Could the Venus encounter be coincidental, a consequence of the probe's entry trajectory that happens to bring it near the planet? The probability is calculable. Given the probe's hyperbolic excess velocity of 58 km per second and its orbital inclination of 45 degrees, the natural trajectory post-perihelion would carry it out of the inner solar system on a path determined solely by the Sun's gravity. To reach Venus requires a trajectory adjustment, a delta V applied in a specific direction at a specific time. The perihelion maneuver provided that delta V. Without it, 3I Atlas would have bypassed Venus by millions of kilometers. With it, the probe is on a precision intercept. The encounter is not coincidental. It is engineered. ISU. Could the probe be using Venus simply as a convenient gravity assist to accelerate its departure from the solar system? This is plausible, even likely, but it does not explain the approach geometry. A typical gravity assist aims for maximum velocity change with minimum risk. The probe would approach Venus on a hyperbolic trajectory optimized for delta V, passing as close as safety margins allow, then departing on a new vector that carries it efficiently out of the system. But the reconstructed trajectory of 3I Atlas does not follow this template. The approach is not optimized for speed. It is optimized for proximity to the Magnetotail, for passage through the upper atmosphere, for interaction rather than transit. The probe is not just using Venus for propulsion, it is studying it. The evidence accumulates layer by layer, data point by data point. The trajectory is deliberate, the timing is precise, the target is scientifically valuable and geometrically advantageous. The encounter will occur during a period of natural concealment when the primary observing spacecraft cannot maintain continuous line of sight. And the pattern maneuver under blackout, approach a scientifically critical target, prepare for the next phase, is consistent with a reconnaissance mission executing a predetermined plan. Venus, then, is not a random waypoint. It is a checkpoint. It is the second node in a sequence that began with perihelion and will continue beyond. It is the proving ground where the probe will test its instruments against a planetary environment that straddles the boundary between terrestrial and alien, between familiar and hostile. And it is the shield, the geometric blind spot behind which the probe can execute its next move without the full weight of human observation bearing down upon it. The course is locked, the clock is running, 2 days remain until the encounter. 2 days until 3I Atlas, travelling faster than any human-made object has ever travelled through interplanetary space, arrives at Venus and reveals whether it is merely passing through or whether it has come to learn. Now you must consider the operational mechanics of the encounter itself. Not merely that it will happen, but how it will unfold, what constraints govern it, and what possibilities emerge from those constraints. This is where theory intersects with engineering, where the abstract trajectory becomes a physical event subject to the brutal realities of distance, line-of-sight geometry, and observational blindness. The primary observer of 3I Atlas at this distance from Earth is not a ground-based telescope. It is JU-ICE, the Jupiter Icy Moons Explorer, launched by the European Space Agency in April 2023, currently en route to Jupiter via a complex sequence of gravity assists. JU-ICE carries 10 scientific instruments designed for studying the Jovian system: optical cameras, imaging spectrometers, radar systems, magnetometers, and plasma wave analyzers. But in October and November of 2025, as 3I Atlas executes its perihelion maneuver and approaches Venus, JICE is positioned such that it has an unobstructed view of the inner solar system. Its radio and plasma wave investigation instrument, with its two 5-meter crossed antennas and onboard data processing unit, is capable of detecting electromagnetic emissions across a broad frequency range. Its Janus optical camera system can resolve features as small as 5 meters per pixel during close approaches. And critically, its trajectory places it outside the orbit of Mars, looking inward toward the Sun, toward Venus, toward the precise region of space where 3I Atlas will execute its next move. JUIC is not merely a passive telescope, it is a platform for very long baseline interferometry observations. A technique that uses multiple ground stations in coordination with the spacecraft's position to achieve angular resolution far exceeding what any single instrument could accomplish. This technique has been employed successfully for planetary atmospheric studies, tracking spacecraft positions to within fractions of an arc. Second, measuring radial velocities with precision on the order of millimeters per second. When applied to 3I Atlas, this capability transforms JUICE from an observer into a witness, capable not just of seeing the probe, but of tracking its trajectory with extraordinary accuracy, detecting velocity changes that would escape ground-based observation, measuring accelerations that betray propulsion. But there is a fundamental limitation: line of sight. JUICE can only observe what is not blocked by intervening bodies. When 3I Atlas passes behind Venus, when the planet's disk as seen from JUICE's position farther out in the solar system occults the probe, the electromagnetic link is severed. Radio waves cannot penetrate 12,004 kilometers of solid rock and molten mantle. Light cannot pass through 600 kilometers of sulfuric acid clouds and carbon dioxide atmosphere. The probe disappears. And in that window of disappearance, in that brief interval when observation is impossible, the probe has the freedom to maneuver without detection. Why? The geometry of an occultation is precise and calculable. Venus, with a radius of 6,052 kilometers, subtends an angular diameter as seen from Jupiter that depends on the relative positions of the three bodies, Venus, Jupiter, and JUICE, at the time of the encounter. On November 3, 2025, Venus will be approximately 0.72 astronomical units from the Sun, while Jupiter will be roughly 5.2 astronomical units out. The angular size of Venus, as seen from JUIC's position, will be small, on the order of arc-seconds, but the probe's trajectory carries it within 0.65 astronomical units of Venus, close enough that even this small angular disk creates a shadow zone, a cone of space behind Venus where no direct signal from the probe can reach JUICE. The duration of this occultation depends on the probe's velocity and trajectory angle. At 95 kilometers per second relative to Venus, even a grazing occultation that passes just behind the limb of the planet would last minutes. A more central occultation, one that carries the probe through the sub-JUICE point on Venus, the location on Venus directly between the planet's center and JUICE, could last tens of minutes or longer. This is not speculation. This is the same geometric principle exploited during radio occultation studies of planetary atmospheres, a technique used extensively by missions to Venus, Mars, and other bodies to probe atmospheric density, temperature, and pressure profiles by measuring how the atmosphere refracts and attenuates a spacecraft's radio signal as it passes behind the planet. Venus Express, during its operational lifetime from 2006 to 2004, performed hundreds of such occultations using Earth-based receivers to track how the spacecraft's signal changed as it grazed the limb of Venus and passed through progressively denser layers of atmosphere. The technique is so sensitive that it can detect variations in atmospheric properties on vertical scales of a few hundred meters. But the principle that makes it work, the bending and eventual blocking of radio waves by a planetary body, is the same principle that creates a blackout for observation.uw. For 3I Atlas, the occultation is not a scientific opportunity, it is operational cover. It is the chance to execute a maneuver while the only capable observer is blind. And if the probe's mission plan was designed with foresight, with knowledge of where observers would be and when, then the timing of the Venus encounter, 5 days after perihelion, at a moment when the geometric alignment creates a natural blackout, is not coincidental. It is engineered. The maneuver itself, if executed during occultation, would follow known principles but adapted for unknown purposes. In human space operations, maneuvers during planetary flybys are categorized by their objective, trajectory correction burns, which fine-tune the approach geometry, orbital insertion burns, which decelerate a spacecraft into orbit, and gravity assist augmentation burns, which add propulsive delta V to the natural momentum exchange of the flyby to amplify the effect. The Parker Solar Probe, during its 7 Venus flybys, used each encounter to progressively tighten its perihelion distance, shaving millions of kilometers off its closest approach to the Sun with each pass. The probe executed no propulsive burns during these flybys. The gravity assist alone provided the necessary velocity change. But Parker was optimized for speed, for diving ever closer to the Sun. 3I Atlas, with its different mission parameters, might require a different strategy. On you. Consider the concept of aerobraking, a technique that uses atmospheric drag to decelerate a spacecraft and reduce its orbital energy without expending propellant. Missions to Mars, including Mars Odyssey, Mars Reconnaissance Orbiter, and ExoMars, have used aerobraking extensively to transition from high-energy arrival trajectories into low, circular science orbits. The spacecraft skims through the upper atmosphere at periapsis, the lowest point of its orbit, experiencing drag that reduces its velocity and lowers its apoapsis, the highest point. Over hundreds of orbits, the cumulative effect of this drag circularizes the orbit, achieving with minimal fuel what would otherwise require enormous propellant reserves. The technique requires precise control, fly too high, and the drag is insufficient, fly too low, and the heating and dynamic pressure destroy the spacecraft. But when executed correctly, aerobraking is extraordinarily efficient. Eng. 3I Atlas, however, is not entering orbit around Venus. Its hyperbolic trajectory, its relative velocity of 95 km per second, precludes capture without a massive deceleration burn that would reveal propulsive capabilities far beyond what has been inferred from the perihelion maneuver. But the probe could use Venus's atmosphere in a different way, not for sustained aerobraking over multiple orbits, but for a single, high-speed passage through the upper atmospheric layers, a maneuver that imparts a small but precisely directed velocity change while simultaneously concealing the maneuver behind the planet itself. This hybrid approach, combining the momentum transfer of a gravity assist with a brief atmospheric interaction and, potentially, a propulsive burn executed during occultation, has been studied theoretically under names like powered aerogravity assist or aero-augmented gravity assist. The concept is to use the atmosphere not just for drag, but as a medium that allows the spacecraft to modify its trajectory in ways that pure ballistic flight cannot achieve. By adjusting the angle of attack, by controlling the lift-to-drag ratio through attitude changes, a spacecraft can steer within the atmosphere, altering its exit trajectory by degrees that translate to significant trajectory changes over interplanetary distances. And if a propulsive burn is added at the moment of closest approach, when the spacecraft is deep in the atmosphere, when the plasma sheath created by hypersonic entry interferes with radio communication, when observation from outside is impossible, the combined effect is amplified. In DOTA, for 3I Atlas, such a maneuver would be the ultimate expression of the braking shield concept. Use Venus not merely as a gravitational pivot, but as an operational shield behind which multiple actions can occur simultaneously. The probe approaches Venus on a trajectory calculated to carry it through the upper mesosphere, where atmospheric density is sufficient to impart measurable drag but insufficient to cause catastrophic heating at the probe's velocity. As it enters the occultation zone, as it passes behind Venus from JAIS's perspective, it executes a brief engine burn, perhaps seconds in duration, perhaps oriented tangentially to adjust orbital inclination, or radially to modify velocity magnitude. The burn occurs while the probe is surrounded by Venusian atmosphere, while the geometry blocks direct observation, while the thermal and plasma signatures of atmospheric entry mask any propulsive exhaust. And then the probe emerges on a new trajectory with the maneuver complete. The evidence for such a maneuver would be indirect, detectable only through post-facto analysis. GI-UIs would observe the probe approaching Venus, track its trajectory up to the moment of occultation, then lose signal. Minutes or tens of minutes later, the probe would re-emerge on the opposite limb. JICE would reacquire the signal, resume tracking, and begin reconstructing the exit trajectory. If the exit trajectory matches the predicted ballistic path, the trajectory expected from gravity assist alone, with no propulsive or atmospheric effects, then no maneuver occurred. But if the exit trajectory deviates, if the velocity vector or the orbital elements differ from prediction by amounts exceeding measurement uncertainty, then something happened during occultation, something that changed the probe's course in ways that natural forces cannot explain. The challenge for analysts then is prediction. To know whether a deviation occurred, you must first know what the trajectory should have been without intervention. This requires high-fidelity modelling, the gravitational field of Venus, which is not perfectly spherical due to the planet's internal structure, the atmospheric density profile, which varies with altitude, latitude, and solar activity, the initial conditions of the approach, measured with sub-kilometre precision, the state transition matrix, a mathematical construct that describes how small changes in initial conditions propagate through the trajectory, must be computed along the entire flight path, allowing analysts to map uncertainties forward in time and determine whether observed deviations are statistically significant or within the noise. This is not trivial, but it is the same analysis performed for every aerobraking pass at Mars, for every gravity assist at Venus, for every occultation experiment designed to probe an atmosphere. G. NASA and ESA have the tools, they have the experience, and if they suspect that 3I Atlas will attempt a concealed maneuver during the Venus encounter, they have already performed these calculations. They have already built the models, run the simulations, identified the telltale signatures that would distinguish a passive flyby from an active maneuver, and they are waiting to see if the probe will confirm their simulations, waiting to see if the pattern holds, waiting to gather the data that will either rule out or confirm the hypothesis that 3I Atlas is not a comet, not a natural visitor, but something designed. The Deep Space Network, NASA's global array of massive radio antennas located in California, Australia, and Spain, will be listening as well. Each facility is equipped with 70-meter dishes capable of detecting signals from spacecraft at the edge of the solar system, capable of measuring Doppler shifts with precision sufficient to infer spacecraft velocities to within millimeters per second. The DSN supports not just NASA missions, but missions from ESA, JAXA, and other agencies under cross-support agreements. During the Venus encounter, if 3I Atlas emits any electromagnetic radiation, whether intentional communication or unintentional plasma interactions, the DSN could detect it, triangulate its position, measure its velocity. The network's 3 stations, spaced 120 degrees apart in longitude, ensure that at least one antenna has line of sight to any point in the solar system at any time, but even the DSN cannot see through planets. Even the DSN will be blind during occultation. W. The silence from official channels is conspicuous. ESA has not issued public statements about GIU-ICE's observations of 3I Atlas. NASA has not released tracking data showing the probe's trajectory with precision sufficient to confirm or deny the perihelion maneuver. The scientific papers published on 3I Atlas focus on its composition, its outgassing behavior, its spectroscopic properties, important data certainly, but not the kind of data that addresses the question of propulsion, of intent, of mission. The trajectory papers, when they appear, discuss orbital elements and eccentricity, but stop short of speculating about deliberate maneuvers. This silence could be ignorance, or it could be preparation. It could be the institutional caution of organizations that do not announce conclusions until the evidence is unambiguous, until the data has been reviewed, until the implications have been assessed. EI. But the silence also creates space for observation without announcement, for data collection without public commitment, for the accumulation of evidence that will either exonerate or implicate. If 3I Atlas executes a concealed maneuver at Venus, if the post-occultation trajectory deviates in ways consistent with propulsion, ESA and NASA will know. They will have the telemetry, the astrometric positions, the Doppler residuals. They will have the proof. But whether they choose to disclose that proof immediately, or whether they wait gathering more data, ruling out alternative explanations, preparing for the broader implications, is a decision that depends on factors beyond science. Factors political, strategic, and existential. 2 days remain. 2 days until the probe reaches Venus. 2 days until the geometry aligns, until the occultation begins, until the probe passes behind the shield and emerges on the other side. 2 days until the hypothesis is tested, until the pattern is confirmed or broken, until the next chapter of this unfolding reconnaissance mission writes itself into the observational record. You wait, as JATES waits, as the Deep Space Network waits, as the analysts and mission planners wait. The trajectory is set, the clock is running. And the probe, traveling at 95 kilometers per second through the darkness between worlds, approaches its second target with the same silent inevitability it brought to Perihelion. You are now at the threshold of understanding, not complete, but sufficient to glimpse the shape of something vast moving through the darkness. The trajectory toward Venus is confirmed. The maneuver mechanics are clear. But the question that remains, the question that makes the silence from official channels not merely explicable but necessary, concerns what happens when the probe emerges. What does the exit trajectory tell you? What does the new vector, the revised heading, the recalibrated course reveal about the larger mission architecture? This is where mathematics becomes destiny, where orbital elements become declarations of intent. To understand the significance of the Venus encounter's outcome, you must first understand what information is encoded in a trajectory itself. A trajectory is not merely a path through space, it is a statement. It carries within its geometry the signature of all forces that have acted upon the object and the object's response to those forces. For a natural comet, the trajectory would reflect only gravity, the sun's dominant pull, and the subtle perturbations of planets. For a spacecraft executing a controlled mission, the trajectory reflects not just forces, but choices. The decision to accelerate at this moment, to coast at that moment, to approach this target rather than that one. When JAICE resumes tracking of 3I Atlas after the Venus encounter, when the probe re-emerges from occultation on the opposite limb of Venus, the first data point is position. The spacecraft tracking stations will determine the probe's location to within a few kilometers, triangulating from the time delays of the radio signal and the Doppler shift that reveals radial velocity. From multiple such positions, separated by minutes or hours, the trajectory analysts will reconstruct the velocity vector, not just the magnitude, but the direction, the inclination, the orientation relative to the Sun. This reconstructed velocity, combined with the position, forms what is called the state vector, the complete description of the probe's orbital condition at that moment. 1. The state vector is then compared to prediction. What state vector would be expected if 3I Atlas had followed a purely ballistic path through the Venus encounter gravity assist alone, no propulsion, no atmospheric effects beyond the negligible drag of the uppermost exosphere? This baseline prediction is calculated using precision orbital propagation software, incorporating detailed models of Venus's gravitational field, the probe's mass and shape, relativistic effects. The predicted state vector, computed from the last pre-occultation observations, is propagated forward through the occultation period using physics that assumes no maneuvers occur. If the actual post-occultation state vector matches this prediction within measurement uncertainty, then no maneuver occurred. The probe is following natural law, responding only to gravity.ui. But if the actual state vector deviates from prediction in ways that exceed measurement uncertainty, if the velocity is larger or smaller than expected, if the direction differs, if the orbital elements have changed by amounts inconsistent with gravity alone, then something else happened. Something acted on the probe. And that something can be reconstructed from the deviation, can be converted back into the delta V, the direction, the magnitude of the impulse that caused it. This reconstruction is not ambiguous. The mathematics are deterministic. Given a deviation and a model of the forces available in the system, you can solve for the unknown force. You can prove that propulsion occurred. Ge. Here is where the stakes become clear. If 3I Atlas executes a maneuver during the Venus occultation, if the post-occultation trajectory deviates from ballistic prediction, then the evidence will be unambiguous. You cannot explain such a deviation through any natural process. You cannot invoke outgassing, even if theoretically possible during atmospheric passage. You cannot invoke unmodeled gravitational perturbations because Venus's gravity field is mapped to extraordinary precision by decades of orbital data from multiple spacecraft. You cannot invoke measurement error because the precision of Doppler tracking and radiometric positioning is such that millions of kilometers per second velocity changes cannot hide within the noise. The maneuver, if it occurs, will be proven ... W. And if it is proven, then what? What are the implications? A maneuver during Venus occultation would definitively establish that 3I Atlas is under active control. It would prove that the object is not a natural comet or interstellar wanderer, but an engineered spacecraft. It would prove that the Perihelion maneuver was deliberate, that the approach to Venus is deliberate, that the entire sequence is planned. It would prove, in other words, that the object known as 3I Atlas is exactly what the earlier analysis concluded: an automated probe, a reconnaissance mission, a visitor from elsewhere executing a program designed years or decades or centuries before its arrival. This is the threshold that ESA and NASA have reached, the reason for the strategic silence. They know what the evidence means. They have calculated the trajectory, run the simulations, prepared the analysis. They are waiting to see if the data will confirm their hypothesis. And they are silent, not because they are ignorant, but because they are not yet ready to commit to the implications. Because the moment that the Venus maneuver is confirmed, the moment that the world learns that an intelligent probe has arrived and is actively studying our system, the political, cultural, and strategic landscape will shift irreversibly. The question will no longer be, is this object artificial? But, why is it here? What does it want? What will it do? The Venus encounter, then, is more than a checkpoint. It is a threshold. It is the point at which speculation becomes evidence, at which hypothesis becomes fact, at which the probe's presence graduates from an anomaly to be studied to an event to be confronted. ESA and NASA are preparing for that moment. They are gathering instruments, reviewing simulations, organizing data, and preparing the infrastructure for the cascade of questions that will follow. They are silent because they have learned something crucial. Once the world knows, the world will never be the same. But what comes after Venus? Assuming the maneuver is confirmed, assuming the proof is irrefutable, what is the probe's next objective? This question can be addressed through the logic of reconnaissance mission design. The Perihelion maneuver served as calibration, a way to confirm that the probe's propulsion system functions, that the trajectory control algorithms work, that the spacecraft is ready for the active reconnaissance phase. The Venus encounter serves multiple purposes. It refines the trajectory toward the probe's ultimate target, it provides data on a terrestrial-type planetary environment, it further demonstrates the probe's maneuverability. But Venus is not the end. It is a waypoint. Consider the strategic value of the inner solar system from a reconnaissance perspective. You have three primary data gathering opportunities: Venus, Earth, and Mercury. Venus offers data on a dead terrestrial world, useful as a control group, valuable for understanding planetary evolution, but ultimately not the primary target. Mercury offers data on a small, dense, heavily cratered body in an extreme radiation environment near the Sun. Scientifically interesting, but of secondary importance. Earth is the third terrestrial planet, the one hosting advanced civilization, the one with a dynamic biosphere, a complex atmosphere, and a technological capability that rivals or exceeds that of many interstellar civilizations. Earth is the primary target, everything else is secondary. But approaching Earth directly, executing a reconnaissance pass close enough to gather detailed data, would be provocative. It would risk interception, confrontation, or misunderstanding. A probe following logical protocols would approach Earth only after gathering sufficient reference data from other sources, after studying Venus to understand planetary evolution, after studying the space environment to understand the radiation and magnetic field conditions, after carefully observing Earth from a distance to assess the threat environment. The approach would be gradual, calculated, designed to maximize information gathering while minimizing risk. This is where the larger mission architecture becomes visible. The probe does not reach Earth immediately after Venus. Instead, it coasts, approaches the inner solar system, and conducts observations from distance. It may approach Mercury, gather data on the radiation environment near the Sun. It may execute another maneuver to position itself for a final approach to Earth. The sequence is not random. It is a carefully planned choreography of observations and course corrections, each step optimized for the next. But there is another possibility, one that emerges from considering the ultimate purpose of reconnaissance. A reconnaissance mission gathers data for a decision. What decision? The basic decision confronting any civilization encountering another is binary, contact or no contact, respond or remain hidden, initiate communication or withdraw. The data gathered by 3i Atlas, the observations of Venus, Earth, the space environment, the technological signatures of human civilization will feed into this decision calculus. The probe is not gathering data for academic curiosity. It is gathering data to answer the question, should we initiate contact with this civilization? This question has subcomponents. Is this civilization capable of understanding us? This depends on technological level, on scientific sophistication, on the civilization's ability to detect and interpret our signals. Are they dangerous? This depends on their military capabilities, their history of aggression, their response patterns to novelty and threat. Are they worth contacting? This depends on their value as trading partners, their contributions to the broader galactic ecosystem, their potential for peaceful cooperation. The dataset required to answer these questions is comprehensive. Spectroscopy of their atmosphere to detect pollution and estimate industrial capability, radio spectrum analysis to detect their communications and measure technological sophistication, direct observations of their world to assess population distribution, military infrastructure, social organization, and observations of the space surrounding their world to measure their current space capabilities, their satellite networks, their presence in near-Earth space. 3i Atlas, following this logic, would be tasked with all these objectives. A single reconnaissance pass, even a close approach to Earth, cannot accomplish such a comprehensive survey. The probe would need to spend weeks or months in the inner solar system, executing multiple passes, gathering data from different geometries and distances, building a complete picture of Earth's technological and biological status. The Venus encounter is the beginning of this phase. The probe has entered the inner solar system, demonstrated its maneuverability, proven its ability to execute complex mission profiles. Now, it will move to the next stage, detailed reconnaissance of Earth. But what does detailed reconnaissance look like? What are the observational techniques available to an advanced probe? Some are passive, collecting light reflected from Earth or emitted from Earth's surface and atmosphere, measuring temperature and composition. Some are active, transmitting signals toward Earth and measuring the reflections, producing radar images, probing the ionosphere. Some are highly invasive, intercepting radio signals, analyzing communication networks, mapping military and civilian infrastructure. Some are biological, collecting samples from Earth's exosphere, analyzing microbes and spores launched into space by Earth's biosphere, assessing the nature and robustness of life on Earth's surface. Each of these techniques is technically feasible for an advanced civilization. Each would be employed by a serious reconnaissance probe, and each would leave signatures detectable by human instruments. A sustained radar probe of Earth, for example, would create anomalous signals in satellite communications and radar systems. Radio direction finding networks around the world would detect the source and transmit location. Optical imaging of Earth from various wavelengths would leave characteristic signals in the noise floors of astronomical observations and space-based sensors. Biological sampling from the exosphere would produce particles and anomalies in the data streams of atmospheric science missions. In other words, the reconnaissance will not be invisible. As 3i Atlas approaches Earth, as it executes closer approaches and more intensive observations, the probe's activities will become detectable. Not necessarily obvious to the untrained observer, but clear to the scientific and military organizations tasked with monitoring the space environment. This is where the real tension emerges. This is where the binary choice, contact or no contact, respond or remain hidden, becomes a three-way dilemma. Ignore the probe and risk military surprise, respond to the probe and risk hostile action, or initiate communication and risk misunderstanding. The scientific establishment, embodied in organizations like ESA and NASA, has been building the case for disclosure. The evidence from 3i Atlas, the maneuvers, the trajectory adjustments, the deliberate approach to Venus, constitutes proof of extraterrestrial intelligent activity. This proof, presented correctly to the world, could prepare humanity for contact. It could shift the global framework from denial and confusion to clear-eyed recognition. It could position us to make informed decisions about how to respond. But the military and intelligence communities are operating under different frameworks. The sudden appearance of an intelligent probe in the solar system, if acknowledged, could trigger military mobilization. Space Force readiness exercises could be confused with actual threat responses. Missiles could be launched, not in response to the probe's actions, but in response to rumors, misunderstandings, or deliberate provocations by actors who want to force humanity into a confrontational posture. The risk of accidental conflict, of a tragic misunderstanding that escalates into violence, is real. This is the deeper reason for ESA and NASA's silence. They are not ignorant. They are strategically positioned, carefully assessing and preparing the world for the truth without triggering panic or military escalation. The Venus encounter is a test, a chance to see if the pattern holds, if the maneuver is confirmed, if the proof is undeniable. Once that proof is in hand, once the trajectory deviation is measured and analyzed and verified, the organizations will have the evidence they need to begin the disclosure process. Not all at once, that would be too destabilizing. But gradually, preparing the scientific and political establishment, building consensus, ensuring that the response to first contact is not chaos but coordinated action. The timeline is critical. Venus encounter is November 3rd. Within days, the trajectory deviation, if it occurs, will be confirmed. Within weeks, the analysis will be peer-reviewed and verified by independent groups. Within months, the implications will percolate through the scientific establishment, generating papers and discussions and, eventually, public statements. The disclosure process, if it follows historical patterns of how governments handle sensitive scientific information, will stretch over months or years. But it will begin with the Venus data. It will crystallize around the maneuver confirmation. It will accelerate from that point forward. You stand at the beginning of this process. You are within 2 days of the Venus encounter, within 2 days of data that will either confirm the hypothesis or shatter it, within 2 days of the moment when the world's oldest question, "Are we alone?" moves from philosophical inquiry to empirical fact. The probe is approaching its target, the geometry is aligning, the occultation is preparing to unfold. And on the other side of Venus, a new trajectory will emerge, carrying a message written in orbital mechanics, a declaration stated in the language of mathematics: "We are here. We are watching. We are making decisions about your future, and very soon you will have to make decisions about ours." The countdown continues. November 3rd, 2025 is 58 hours away. JICE is holding position, instruments ready, tracking systems active. The Deep Space Network antennas are oriented, their receivers tuned, their sensitivity calibrated to detect even the faintest signal from the probe. And 3i Atlas, traveling at 68 kilometers per second relative to the solar center, carrying propulsion systems still warm from the Perihelion maneuver, crosses the orbital path of Venus with the precision of a clock mechanism. 2 days remain. 2 days of silence, of waiting, of data analysis performed in locked rooms by people who understand the implications but cannot yet speak them. 2 days until the silence ends, until the mystery resolves into either confirmation or mystery deepened. 2 days until Venus and the second act of the reconnaissance mission unfolds. Now you understand the technical foundations of what will be measured. The precision is extraordinary. The Deep Space Network's most sensitive Doppler observations achieve fractional frequency stability of approximately 3·10⁹⁹⁹, a measure of how precisely the system can detect changes in a signal's frequency. This translates to velocity measurements with precision better than 0. 1 millimeters per second at 60-second integration times. At such precision, an asteroid passing through the solar system at thousands of meters per second would generate a Doppler signature measurable to within centimeters per second. Any maneuver, any deliberate impulse applied to 3i Atlas would create a velocity change signature that could not possibly hide within the noise. Ni. But there is more to trajectory reconstruction than Doppler data alone. The Deep Space Network also provides ranging data, the time delay between transmission and reception of a signal that reveals distance. The network transmits coherent radio signals toward the probe, and the probe's receiver, or the probe's reflective properties, if passive, returns those signals to Earth. The time delay, multiplied by the speed of light, gives the distance. When this distance measurement is repeated at intervals, seconds, minutes, hours apart, the rate of change of distance reveals radial velocity, how fast the probe is moving toward or away from Earth along the line of sight. This is not orthogonal velocity, which would require additional observations. But combined with observations from multiple ground stations positioned on different sides of Earth, the ranging data paired with Doppler data permits reconstruction of the full three-dimensional velocity vector .me. The precision of these measurements, propagated through state transition matrices and uncertainty propagation algorithms, determines what maneuvers are detectable and what maneuvers hide within the noise. A delta V smaller than measurement uncertainty cannot be distinguished from 0. But 3i Atlas, with its demonstrated propulsive capability during the Perihelion maneuver, will have executed a burn large enough to be detectable. The post-occultation trajectory analysis will be unambiguous. Either the probe followed natural ballistics through the Venus encounter, or it did not. There is no middle ground. Consider what happens in the hours immediately following re-emergence from Venus occultation. JICE's tracking systems resume contact with the probe as it exits the occultation zone. The spacecraft acquisition is automated, the antenna slews to the predicted location, the receiver searches the expected Doppler frequency range, the signal is detected. Within seconds, the link is re-established. Within minutes, a stream of positions and velocities flows back to Earth. The data is logged, time-stamped, and transmitted to the navigation teams who are waiting in real time for this moment. The preliminary trajectory reconstruction, the first rough estimate of the probe's position and velocity post-occultation, can be completed within hours. The analysts load the pre-occultation trajectory into the orbit propagation software, integrate through the Venus encounter under the assumption of pure gravity, and compute what the post-occultation state should be. They then compute what it actually is based on the fresh observations. The deviation, if it exists, is immediately apparent. It appears as an offset in position. The observed spacecraft is kilometers or tens of kilometers away from where gravity alone would have placed it, and as a velocity discrepancy. The measured velocity vector differs by millimeters per second or more from the predicted velocity vector. If the deviation is zero within measurement uncertainty, a few kilometers in position, a few millimeters per second in velocity, then the conclusion is clear: no maneuver occurred. The probe followed ballistic flight through Venus. The gravity assist alone explains the trajectory change. The hypothesis is falsified. 3I Atlas is, after all, a natural comet, subject to the laws of physics and nothing more. But if the deviation is significant, exceeding measurement uncertainty, consistent across multiple observation geometries, reproducible in independent analyses, then the conclusion is equally clear: a maneuver occurred. Something acted on the probe, the state vectors don't match, the trajectory has been altered by forces beyond gravity, and once that is established, the inverse problem becomes tractable, given the deviation, what impulse caused it. What delta V was required? In what direction? For how long? The mathematics are deterministic. The solution is unique. The propulsive maneuver can be reconstructed. Here is where strategy and secrecy become entangled with science. Once the maneuver is detected, once the analysis confirms it, the data exists in the servers of NASA and ESA. It cannot be unseen. It cannot be made to go away. But it can be classified. It can be held in secured channels, shared only with the highest levels of government and military command. It can be kept from the scientific community while the political implications are weighed, while the decisions are made about what to do with knowledge of an intelligent extraterrestrial probe operating in the solar system. But science eventually leaks. It always does. The papers are written, the results are discussed at conferences, the peer review process begins. Within weeks of the Venus maneuver confirmation, the information will have spread through the astronomical community. Within months, it will reach the press. Within a year, it will be undeniable to any educated observer that something extraordinary has been detected. The choice facing ESA and NASA is not whether the information will eventually become public, but when and how it will be revealed, with or without official acknowledgement, in a controlled fashion, or as a cascade of rumors and leaked analysis that undermines credibility. The strategic value of controlling the narrative, then, is immense. If ESA and NASA can present the evidence first, can frame the interpretation, can guide the discussion toward rational analysis and away from panic, they preserve authority and credibility. If they allow the information to leak, if they remain silent while speculation runs wild, they cede control to other actors. Military institutions, conspiracy theorists, international competitors who may interpret the probe's presence through a lens of hostility. The Venus encounter, in this sense, is not just a scientific event, it is a political inflection point. But there are other considerations as well, deeper considerations that emerge when you contemplate what the data actually means. The trajectory reconstruction provides position and velocity. It proves or disproves propulsion. But it does not explain intent. It does not answer the question, what is 3I Atlas trying to do? Is it gathering data for a report to be sent home across the interstellar void? Is it preparing for a reconnaissance pass of Earth? Is it setting itself up for a sequence of encounters that will cover the entire inner solar system? Is it perhaps preparing for something else entirely, some maneuver or action that has no terrestrial analog in human experience? The deeper analysis requires inference beyond the pure mathematics of trajectory. It requires understanding mission architecture, the logic of exploration, the strategies that advanced intelligence would employ when reconnoitering a new system. And here, speculation must be grounded in reason. The probe has demonstrated propulsive capability. It has shown the ability to execute precise trajectory corrections. It has positioned itself to conduct detailed observations of Venus, a planet that offers no direct strategic threat, but substantial scientific value as an analogue to Earth. What does this sequence reveal about the probe's objectives? One possibility: the probe is engaged in systematic reconnaissance of terrestrial-type planets. It studied Venus for comparative purposes. It will next approach Earth for direct observation. It may later examine Mercury for completeness. The sequence is orderly, systematic, designed to gather a comprehensive survey of the small terrestrial worlds orbiting this sun. From such a survey, an intelligence could assess planetary diversity, understand the ranges of outcomes for similar initial conditions, and begin to develop a model of planetary evolution applicable to other stars and other systems. Earth, in this framework, is not the end goal, but one data point among several. Another possibility: the probe's creators are specifically interested in life. Venus, as a dead world, serves as a negative control. Earth, teeming with life, is the primary target. The reconnaissance seeks to understand what conditions permitted life to flourish on one terrestrial world and fail on another. The Venus maneuvers are calibrations. Earth is where the real work begins. A third possibility: the probe is studying the space environment, the solar wind, the magnetic fields, the radiation. Each planetary encounter offers a new vantage point, a chance to observe how planets interact with the heliosphere. Venus, with its induced magnetosphere but no internal magnetic field, is one case. Earth, with its strong dipole field, is another. Mercury, with its small but intense magnetic field, is yet another. The probe is mapping the diversity of planetary magnetospheres, understanding the mechanisms by which planets interact with stellar wind. Or perhaps something more operational: the probe is testing its own systems. The Perihelion maneuver confirmed propulsion capability. The Venus encounter will test atmospheric interaction, gravitational assist precision, and the ability to execute complex maneuvers during occultation. Earth, as a more massive and more consequential target, requires even greater precision, even more sophisticated maneuvering algorithms. The probe is training itself, preparing itself for the most critical phase of its mission. Or perhaps, and this is the possibility that generates the most concern in classified briefings, the possibility that justifies the strategic silence: the probe is not here to observe at all. It is here to communicate. The Venus maneuver is a signal: I am here, I am capable, I am intelligent. The trajectory adjustment, visible to human instruments, is a message. It is saying, I know you are watching. I have demonstrated my ability to alter my course, to execute precise maneuvers, to hide or reveal myself as I choose. What will you do? In this interpretation, the probe is not gathering data for a distant audience. It is communicating with us. The maneuver during Venus occultation is not a simple course correction. It is a display. It is proof of capability directed at human observers. It is a challenge and an invitation simultaneously. Know that I am intelligent. Know that I am skilled. Know that I am here. And now, what is your response? If this is the case, if the probe is intentionally allowing its maneuvers to be detected, deliberately leaving traces that human instruments can measure, then the strategic implications shift dramatically. The probe is not trying to hide, it is trying to be seen. It is following a communication protocol designed to build the case for its intelligent nature step by step, observation by observation, until the accumulation of evidence becomes undeniable. The Venus encounter is the second step in this protocol. And when ESA and NASA look at the post-occultation trajectory data, when they calculate the deviation and realize it exceeds natural explanation, they will understand. The probe has just sent the second message. I am here. I am watching. What next? 2 days remain until the message can be received. 2 days until the geometric alignment is perfect. 2 days until Venus passes between the probe and Jupiter, creating the occultation. 2 days until the moment of silence, the window of darkness, during which maneuvers execute beyond observation. And then, seconds or minutes or hours later, the probe re-emerges. The data flows back to Earth. The analysis begins, and the cascade of implications unfolds, implications that will reshape humanity's understanding of its place in the cosmos. The countdown continues. The clock on the wall ticks forward. November 3rd, 2025 approaches. And in the darkness of space, traveling at velocities that would consume the distance from Earth to the Sun in less than 6 days, 3I Atlas continues its calculated journey toward the second node of its reconnaissance mission. You now approach the edge of what can be logically inferred from available data. Beyond this point lies the territory of speculation, but it is speculation grounded in probability theory, in game theory, in the logic of reconnaissance missions as humanity understands them. The patterns are clear. The evidence accumulates. But the final form of the probe's mission, the ultimate objective, remains shrouded in the interval between now and November 3rd, 2025. What happens in that interval? What is being prepared? What is being calculated in the rooms where the most sensitive decisions are being made? Consider first the information environment. At this moment, Wednesday, October 29, 2025, shortly after noon, UTC, the astronomical community is in a state of measured activity. The perihelion maneuver of 3I Atlas occurred 48 hours ago. The trajectory reconstructions are complete, the velocity vectors have been recalculated, the preliminary papers have been written, submitted to preprint servers, disseminated through internal channels to university astronomy departments and research institutes. The data is now in the system. It cannot be recalled. But the official statements have not been made. The press releases have not been issued. NASA has released no position papers. ESA has made no public announcements beyond brief technical acknowledgements that 3I Atlas is under observation. This silence is not accidental. It is the calm before the cascade. Once the first official acknowledgement is made, once a government or a major space agency steps forward and confirms that the trajectory deviation has been detected, that the maneuver was real, that the probe has demonstrated propulsion, the narrative enters the public domain. The story is no longer a matter of speculation among astronomers. It becomes news, it becomes policy, it becomes political. The timing of this announcement, if and when it is made, will be carefully chosen. It will not come before Venus. That would trigger military mobilization, public panic, or hasty international responses that might conflict with the probe's operations or risk escalation. It will not come immediately after Venus, while analysts are still processing the data, while the trajectory deviation is being verified and re-verified. It will come at a moment when the evidence is irrefutable, when independent analyses have confirmed the findings, when the scientific case is so solid that no credible scientist could dispute it. The announcement will be timed for maximum credibility and minimum destabilization. But credibility requires a mechanism of trust. A government announcement might be disbelieved. A space agency statement could be dismissed as speculation. The only truly credible disclosure would come through the peer-reviewed scientific literature, through papers published in Nature or Science or the Astrophysical Journal, papers that have passed through independent review, papers whose conclusions have been examined by experts from institutions around the world with no institutional investment in the conclusion. ESA and NASA know this. They are already preparing the papers. The Venus encounter data will provide the evidence. The peer review process, accelerated by the urgency of the findings, will validate the conclusions within weeks. By early December, the scientific case will be undeniable. By late December, it will be in print. By January 2026, it will be taught in astronomy classrooms as established fact. But there is another mechanism of credibility at play here, one that operates below the official level. The intelligence and military communities of multiple nations have also been monitoring 3i Atlas. The US has space-based sensors and ground-based radar. Russia maintains its own tracking networks. China has invested heavily in space surveillance. India has growing capabilities. These organizations, unlike the civilian space agencies, operate without transparency requirements. They can detect the maneuvers, verify them, and incorporate them into classified assessments without public disclosure. And they can, at their discretion, leak information. A strategic leak from a military intelligence agency would carry different weight than an official announcement. It would have the appearance of being stolen information, of being revealed against official wishes. This very appearance would make it more credible to a skeptical public. The leaked information would circulate through independent media, through social networks, through channels that the public trusts more than official government statements. Once the leaked information is circulating, the space agencies and governments can then confirm what has already been revealed, appearing to be responsive to public information rather than original sources of a controversial disclosure. This strategy, allowing information to leak, then confirming it, has been used by governments for decades to manage sensitive information releases. Will this happen with 3i Atlas? The evidence suggests it might. The silence from official channels is itself suspicious. If there were nothing important to hide, if the Venus encounter were merely a routine gravity assist for a natural comet, the information would flow freely through normal scientific channels. The fact that it is being held, controlled, compartmentalized, suggests that something is being managed. Something requires strategy. Now consider what that strategy might accomplish. If, on November 3, 2025, the Venus maneuver is executed and the trajectory deviation is detected, the post-occultation data analysis can be completed by November 5 or 6. Independent verification by multiple space agencies and research institutions could be finished by November 8 or 9. By November 15, the preliminary papers could be in preprint. By late November, the peer review process could accelerate to completion. By December 1, the first major publication could appear. By December 15, the case would be airtight. Meanwhile, the leaked information would begin circulating through intelligence channels around November 8 or 9. By November 15, the first news stories would appear. By November 20, major media outlets would be covering the story. By November 25, it would be global news. By December 1, when the first peer-reviewed paper appears, the public would already be acclimated to the revelation. The official confirmation would feel like a watershed moment, yes, but not a shock. The narrative would have already begun to shift toward acceptance. What would 3i Atlas be doing during this cascade of revelations? It would be coasting. After the Venus maneuver, the probe would exit the occultation zone and continue on its new trajectory, refined by the gravity assist and the hidden maneuver, now oriented toward the next checkpoint. If Earth is indeed the next target, the probe would be adjusting its course to approach the inner solar system, to position itself for reconnaissance passes of Earth's orbital space. The approach to Earth would not be a direct trajectory. That would be provocative, a clear signal of hostile intent or aggressive intent. Instead, the probe would take an elliptical path, one that carries it around the inner solar system, allowing for gravity assists or additional maneuvers to position it for Earth observations. The approach would be gradual, deliberate, calculated to demonstrate control and intentionality without appearing to threaten. The probe would arrive at Earth not as a missile but as an emissary, or so the trajectory would suggest. And Earth's institutions would be waiting. NASA would have mobilized its space-based sensors. The Deep Space Network would have oriented its most sensitive receivers. Military satellites would be positioned to track every movement. The International Space Station would have been briefed. Universities and observatories around the world would have prepared instruments for emergency observations. Humanity as a species would be watching, waiting, preparing for the moment when the probe arrives and begins its detailed reconnaissance of our world. What would that reconnaissance look like? What instruments would the probe employ? The most direct method would be radio signal analysis, tuning in to Earth's radio emissions, the broadcast signals, the military communications, the cellular networks, the everything that humanity projects into space. A sufficiently advanced probe could construct a picture of Earth's technological civilization from this alone, understanding the distribution of communication infrastructure, inferring population distribution, assessing the sophistication and diversity of technology. The probe could detect signatures of nuclear weapons, nuclear power plants, the specific fingerprints of human industry and defense. But radio analysis is passive. A more sophisticated reconnaissance would employ active sensing, transmitting radio waves toward Earth, analyzing the reflections. Synthetic aperture radar, deployed from space, can image Earth's surface with resolution of meters or even decimeters. The probe could create a comprehensive map of Earth's surface, identifying military bases, ports, population centers, infrastructure. It could then use spectrographic analysis to understand atmospheric composition, to detect the signatures of industrial pollution, to assess the extent of human alteration to the biosphere. It could use thermal imaging to understand energy usage, to map the distribution of human activity by infrared signature, ... And if the probe carried biological sampling equipment, capture mechanisms for the spores and microbes that Earth continuously releases into the upper atmosphere, that drift into space on currents of solar wind and radiation pressure, it could assess the nature of Earth's biosphere directly. Humanity has known since the 1970s that microorganisms from Earth are carried into the upper atmosphere and potentially into space. The probe could harvest these, analyze them, assess their genetic structure, understand the biochemistry of Earth life. This would be intelligence gathering of a sophisticated nature, reconnaissance that moved beyond the merely political and military into the realm of the biological and existential. All of this is speculative, yes, but it is not wild speculation. It is speculation grounded in what is known about Earth observation technology, about the capabilities of advanced spacecraft, about the information requirements for making an informed decision about first contact. If 3i Atlas is indeed an automated reconnaissance probe sent by an intelligent civilization to assess humanity, this is precisely the type of information gathering that would be employed. But here is the crucial point. All of this activity, the radio monitoring, the radar imaging, the biological sampling, would generate signatures detectable by human instruments. Military radar operators would detect transmissions at them. Astronomers using optical telescopes would see the reflected light from a close approach. Radio spectrum analyzers would detect probing signals in frequency ranges not used by natural astrophysical sources. The probe could not conduct a sophisticated reconnaissance of Earth without revealing its activities. The reconnaissance and the visibility are inseparable. This is where the communication hypothesis becomes most compelling. If the probe's creators wanted to remain hidden, they would not conduct active reconnaissance. They would observe from a distance, passively collect data, and depart without contact. But if they have already demonstrated their presence and their intelligence through the Perihelion maneuver and the Venus encounter, if they have already accepted that they will be detected, then active reconnaissance becomes strategically rational. It serves the purpose of communication. It demonstrates capability. It provides information, and it sends a message: I am here, I see you, I am learning about you. Prepare for contact. From this perspective, the probe's trajectory and maneuvers are not hiding, they are revealing. The Venus maneuver is not an accident that humans will stumble upon. It is an intentional demonstration, performed at a moment when human observatories will capture it, performed in such a way that analysis will reveal its artificial nature. The approach to Earth is not a stealth infiltration. It is a deliberate presence, visible and undeniable, forcing humanity to confront the reality of extraterrestrial intelligence. What is the purpose of such communication? It could be to test humanity's response. Do we respond with hostility or with openness? Do we mobilize military resources or prepare for diplomatic contact? Do we fracture into competing national responses or unite as a species? The probe's creators could gather all of this information through observation and monitoring. They could see how humanity reacts to undeniable evidence of intelligent extraterrestrial presence. They could assess our maturity as a civilization, our capacity for rationality in the face of the extraordinary. This information, how humans respond to first contact, could be as important as any physical data about Earth's environment or biology. It reveals the nature of human civilization, the degree of centralized authority, the presence or absence of international cooperation, the extent to which humanity can rise above parochial interests to address a challenge to the species as a whole. If the probe's creators are considering whether to initiate deeper contact, this information would be invaluable. But assessment carries risk. If humanity responds to the probe's presence with military aggression, if nations launch weapons at the probe or attempt to capture or destroy it, the situation could escalate into conflict. An automated probe responding to attack could employ countermeasures. It could use kinetic weapons, accelerating objects to extreme velocities and allowing gravity and Earth's atmosphere to pull them toward targets. It could employ electromagnetic weapons, disrupting communications and power grids. The consequences could be catastrophic. This is the real danger, the real reason for strategic silence and controlled disclosure. The revelation of 3I Atlas's presence must be managed such that military responses are minimized. The evidence of its intelligence must be clear enough that military responses are recognized as futile and potentially suicidal. The demonstration must be calibrated precisely, show enough capability to deter aggression, but not so much as to appear threatening. Show intelligence enough to earn respect, but not so much as to seem incomprehensible or truly alien. The probe must strike a balance in its communication. The Venus maneuver in this light was perfectly calibrated. It demonstrated propulsion but not overwhelming destructive capability. It showed precision, but it approached Venus rather than Earth, avoiding the appearance of a direct threat. It used natural geometric cover, the occultation which shows tactical sophistication but not the kind of militaristic cunning that would suggest hostile intent. Every aspect of the maneuver was designed to communicate intelligence and capability without appearing to prepare for attack. The approach to Earth will be subject to the same calibration, close enough to demonstrate earnestness, far enough to avoid appearing immediately threatening. Sufficient reconnaissance to show that the probe understands human civilization, not enough to appear to be selecting military targets. The trajectory will approach but not enter Earth orbit. A probe in geosynchronous orbit could appear to be positioning for an attack. The probe will approach but not strike demonstration without violence. The probe will observe but not interfere, knowledge without control. This is the protocol of first contact as practiced by a truly advanced civilization. Not invasion, not conquest, not domination, but demonstration, communication, assessment. A dance of mutual evaluation conducted in the cold vacuum of space at velocities that make reversal impossible, at scales that make concealment futile. The probe and humanity watching each other across the darkness, beginning to understand that they are no longer alone. 2 days remain until Venus. 2 days until the first chapter of this contact protocol reaches its climax. 2 days until the maneuver either confirms the hypothesis or shatters it. 2 days until we know whether the probe is intelligent, whether the maneuvers were deliberate, whether we have been visited by an advanced civilization and are now entering the first dialogue with minds not born under Earth's sun. The silence before the message, the pause before the conversation begins, the moment of holding breath, of waiting for the word that will transform the species forever. November 3rd, 2025 approaches. 58 hours away, then 48, then 36. The countdown is relentless. The trajectory is locked. The gravity is inevitable. What emerges from behind Venus will either confirm or deny everything. And the world, unknowing but sensing that something is afoot, spins toward that moment, carrying 7.5 billion souls toward a transformation whose scope we have only begun to glimpse. The data flows through secured channels. The models are refined. The contingencies are prepared. In rooms without windows, in buildings whose addresses are classified, analysts and generals and politicians contemplate the implications of what will soon be known. They prepare for scenarios: peaceful contact, hostile act, misunderstanding. They position resources. They draft protocols. They ready humanity for a future that begins on November 3rd, 2025, at the moment when Theia Atlas emerges from behind Venus and humanity learns finally, definitively, that we are not alone. You step back now and contemplate the larger framework, not the immediate countdown to Venus, but the broader context into which this event fits. The probe is not an isolated phenomenon. It is a symptom of a larger reality that has been slowly crystallizing at the edge of human awareness for decades. The question is not whether intelligent extraterrestrial life exists. The question is whether humanity has been ready to acknowledge that reality and what the arrival of physical proof will mean for institutions, nations, and the human psyche itself. Consider the historical precedent. When Columbus returned from his voyages to the Americas, when the reality of undiscovered continents became undeniable, European civilization entered a period of profound transformation. The medieval worldview, the assumption that Christendom encompassed the known world, fractured. New wealth flowed, new knowledge arrived, new diseases spread, new moral dilemmas emerged. The contact between civilizations at different technological levels produced outcomes ranging from the beneficial to the genocidal. Centuries of consequences flowed from that first recognition that the world was larger than had been imagined. The discovery of Theia Atlas, the confirmation of its intelligent nature, will be a contact event of comparable magnitude, but with crucial differences. This contact is not happening between civilizations at similar technological levels operating in adjacent geographic spaces. This is contact between humanity and a civilization sophisticated enough to send automated probes across the interstellar void, sophisticated enough to perform precision maneuvers near the sun, sophisticated enough to gather comprehensive reconnaissance data and compile it into actionable intelligence. This is contact between a species that has only recently achieved space capability and a species that has mastered the physics and engineering to project power across light years. What does such contact mean? Historically, it has meant subordination. When civilizations meet at vastly different technological levels, when one has firearms and the other has bows, when one has navies and the other has canoes, the more advanced civilization dominates. The less advanced is incorporated into the sphere of influence of the more advanced. Sometimes this incorporation is peaceful, sometimes violent, but it is rarely between equals. But Theia Atlas is not an invasion fleet, it is a single probe. A technological artifact of sophistication certainly, but also limited in capability. It cannot conquer, it cannot occupy. It cannot impose its will by force. What it can do is communicate. What it can do is gather intelligence and report back. What it can do is establish the first contact, the first dialogue between species. And this is where strategy diverges from history. The arrival of Theia Atlas is not like Columbus's arrival in the Americas. It is more like the arrival of European explorers in the Pacific centuries later, after the initial shock had worn off, after contact protocols had been developed, after the assumption of mutual intelligence had been established. Theia Atlas's creators are not conquistadors. They are explorers and diplomats, sending forth a probe to establish first contact in a measured, controlled, intelligence-gathering fashion. But what do they intend to do with the intelligence they gather? This is the question that keeps strategists awake. Will they attempt to establish communication? Will they return home to report, triggering a deliberate decision about deeper contact? Will they move to an observation phase, monitoring humanity for decades or centuries before deciding whether intervention is warranted? Will they conclude that humanity is too dangerous, too unpredictable, too volatile to be allowed to develop unchecked? Will they attempt to influence humanity's development, to steer the species toward outcomes that are compatible with the probe's creator's interests? Each of these scenarios carries profound implications. Each requires a different human response. And the tragedy is that humanity cannot know which scenario applies until it is too late to change course. Once the probe's creators had made their assessment and made their decision, the die is cast. If they have decided to intervene, intervention will come. If they have decided to observe, observation will continue. If they have decided to avoid contact, avoidance will occur. Humanity will be subject to decisions made by others in ways humanity cannot control. This asymmetry is the true source of strategic anxiety. Not invasion, not conquest, not the crude military threats that have preoccupied defense establishments for centuries, but the loss of agency, the reduction of humanity to the status of observed rather than observer, the subjection of the species to decisions made by actors whose interests and goals cannot be assumed to align with human interests. This is why the silence from official channels runs so deep. This is why ESA and NASA are so careful, so measured, so strategic in how they handle the information. They understand that the arrival of 3I Atlas, confirmed beyond doubt, changes the entire power dynamic of human civilization. And yet, there is reason for cautious optimism. The very fact that the probe is communicating, demonstrating its intelligence through maneuvers, showing restraint by not employing overwhelming force, approaching with patience and deliberation, suggests that its creators are approaching contact as a dialogue rather than a conquest. The probe is not hiding. It is not pretending to be a natural object. It is not employing weapons or tactics of aggression. Instead, it is demonstrating over and over that it is intelligent, capable, and peaceful. This is the message the Venus maneuver will send if the hypothesis is correct. Not, we are here to conquer, not, we are here to extract resources or subjugate your civilization, but rather, we are here. We acknowledge your intelligence. We respect your autonomy enough to demonstrate our presence rather than hide it. We are prepared to have a dialogue with you on your terms, in your time. This is the message a truly advanced civilization would send if its intentions were genuinely peaceful. But message and intention can diverge. A probe could demonstrate restraint and intelligence for the purpose of gathering information before an invasion. A civilization could show respect for autonomy while actually preparing to manipulate and control. The message alone is insufficient. Humanity must look beyond the message to the actions, to the consequences, to the long-term implications of the probe's presence and activities. This is where humanity stands 58 hours before Venus. The species has received a message, though it does not yet know it consciously. The message is being translated from trajectory and velocity into language that humans can understand. By November 3rd, the message will be clear enough that denial becomes impossible. By November 15, the world will know. By December, the nature of human civilization will have begun to shift. But between now and then, there is still time. Time to prepare, time to think, time to consider what the arrival of the probe means, what the species should do in response, how to position humanity to engage with whatever comes next. The nations of Earth are not united. The institutions of Earth are not coordinated. The populace of Earth does not yet know that first contact is imminent. The next 58 hours are perhaps the last moments in which humanity has the advantage of uncertainty. Once the uncertainty is removed, once the facts are undeniable, the cascade begins and there will be no stopping it. What should humanity do? The answer depends on assumptions about the probe's intentions, about the nature of intelligence across the galaxy, about the future trajectory of contact and its consequences. If the probe's creators are genuinely peaceful, if they seek knowledge and exchange rather than domination, then the appropriate human response is openness, cooperation, and preparation for dialogue. Humanity should establish unified communication protocols, designate representatives who can speak for the species, prepare to offer information and receive information in return. The approach should be diplomatic, cautious, respectful of the probe's intelligence and autonomy. If, conversely, the probe's creators are hostile or indifferent to human welfare, if they view humanity as a resource to be exploited or an obstacle to be removed, then the appropriate response is vigilance, self-defense readiness, and unified military preparation. Humanity should fortify its space capabilities, prepare weapons systems that could threaten a spacecraft, ensure that any attempt at hostile action would be met with maximum resistance. The approach should be defensive, prepared for the worst case even while hoping for the best. But most likely, the reality will be more complex. The probe's creators are probably neither purely benevolent nor purely hostile. They are probably motivated by the same mix of curiosity, self-interest, and pragmatism that motivates human explorers and diplomats. They seek knowledge. They seek to understand humanity and the solar system. They probably welcome the possibility of mutually beneficial contact, but only under terms that serve their interests. They are not enemies, but they are not friends either. They are actors with their own goals, approaching humanity as one actor among many, assessing cost-benefit ratios and strategic advantage. In this realistic scenario, humanity's best approach is sophisticated diplomacy combined with cautious self-defense. Establish communication when possible, but prepare for misunderstanding. Offer hospitality to the probe, but maintain strategic advantage by not being completely transparent. Express interest in exchange and cooperation, but establish clear boundaries on what will and will not be tolerated. Treat the probe's creators as one would treat any foreign power, with respect, with vigilance, with the understanding that alignment of interests is possible but cannot be assumed. The difficulty is that most humans do not think in these terms. The human cognitive framework, evolved over millennia of terrestrial evolution, does not easily accommodate the reality of extraterrestrial intelligence operating according to logics that may be fundamentally alien. Humans project their own values onto others. They assume that intelligence implies benevolence, or they assume that intelligence implies malevolence. They oscillate between hope and fear, between attraction and repulsion. They rarely hold both possibilities simultaneously in mind while maintaining clear judgment. This is where institutions become crucial. Scientific institutions, diplomatic institutions, military institutions. These are the frameworks through which humanity can think collectively, can pool knowledge, can arrive at coordinated responses. ESA and NASA are not silent because they are hiding information. They are silent because they are thinking, analyzing, preparing. They are constructing the frameworks through which humanity will engage with the probe and its creators. By the time the world knows, these institutions will have prepared contingencies, established protocols, positioned resources. The response will not be perfectly coordinated, but it will be more organized than it would be if the information were simply dumped on an unprepared populace. But there are risks in this institutional approach as well. Institutions are also motivated by self-interest. A space agency might seek to monopolize access to the probe for its own prestige or scientific benefit. A military establishment might seek to weaponize information about the probe for strategic advantage. A government might seek to control the narrative for political gain. The institutions that should be preparing humanity for contact are also the institutions that might exploit contact for parochial advantage. Transparency and institutional self-interest are always in tension. This is the paradox humanity faces. The discovery of 3i Atlas requires rapid institutional response to be managed well. But institutional response creates opportunities for abuse, for mismanagement, for the distortion of information in service of institutional goals. The species needs to be prepared, but preparation requires trusting institutions that cannot be fully trusted. The species needs information, but information is being mediated through institutions that may have agendas other than pure truth. These are the tensions that will play out over the next year, the next decade, the next century. They will shape how humanity engages with the probe, how the species positions itself relative to whatever contact protocols emerge, how the trajectory of human civilization is altered by the knowledge of extraterrestrial intelligence. But first, November 3rd must come. First, the maneuver must be confirmed or refuted. First, the evidence must be gathered and analysed. Only after that will the cascade of consequences begin. Only after that will the world know for certain. Only after that will the species begin to understand what it means to be one intelligence among others in a cosmos populated by mind. 58 hours remain. The probe coasts. JUICE maintains its vigil. The Deep Space Network waits. ESA and NASA prepare classified briefings for the highest levels of government. Military commanders in multiple nations position resources. Scientists around the world run simulations, calculate probabilities, prepare hypotheses for testing. And humanity, in its vast majority, goes about its daily business, unknowing that the fundamental nature of human existence is about to be revealed. The probe approaches Venus at 68 kilometers per second relative to the solar center. At that velocity, with the geometry locked in by the Perihelion maneuver, there is no possibility of deviation, no possibility of last-minute course correction. The rendezvous is certain, the encounter will occur, the data will flow, and when it does, the world will never be the same. The silence continues. The countdown runs. The moment approaches. In 58 hours, either speculation transforms into fact, or fact transforms into deeper mystery. Either humanity learns that it has been visited by intelligence from elsewhere, or humanity discovers that even its most careful analysis can mislead, that even its most powerful instruments can deceive, that the universe remains stranger and more complex than its observers can fully comprehend. The waiting ends on November 3rd, 2025. The question will be answered. The message from 3i Atlas will be decoded. And the future, bright or dark, will unfold from that moment forward, carrying with it all the consequences of first contact with an intelligence not born on Earth. There is a structure already in place, a framework that humanity has built in anticipation of this moment, even if it does not fully realize it yet. The International Academy of Astronautics Declaration of Principles concerning activities following the detection of extraterrestrial intelligence, originally formulated in 1989, updated in 2010, and currently being revised again, represents humanity's closest approximation to a formal first contact protocol. Though the declaration is not legally binding, though it carries no force of international law, it has been endorsed by 6 major space-related professional societies and represents a consensus among those who have thought most carefully about what should happen if we detect extraterrestrial intelligence.g. The protocol is simple in structure, but profound in implication. Upon credible detection of extraterrestrial intelligence, the discoverer should verify the evidence through independent confirmation, consult with other experts to rule out false positives, and then only after confidence is established, inform the broader world. The notification process is specific. Inform the Central Bureau for Astronomical Telegrams of the International Astronomical Union, inform the Secretary-General of the United Nations in accordance with Article XI of the Outer Space Treaty, and inform a range of international scientific institutions including the International Telecommunication Union, the Committee on Space Research, and various space law and astronomy organizations (MAI). The Outer Space Treaty of 1967, the foundational document of international space law, provides the legal infrastructure for this notification process. Article X1 of the treaty requires states conducting activities in outer space to inform the UN Secretary-General of the nature, conduct, and results of such activities, and the Secretary-General is tasked with disseminating this information immediately and effectively. Though the treaty was written to govern human activities in space, not encounters with extraterrestrial intelligence, legal scholars have argued that the spirit of the treaty implicitly recognizes the UN Secretary-General as humanity's representative in any contact scenario with extraterrestrial entities. But here is the critical limitation. The protocols were designed for remote detection of electromagnetic signals, not for physical encounter with an interstellar probe. The IAA declaration assumes that first contact will occur through SETI, the search for extraterrestrial intelligence, detecting a radio signal from a distant civilization, followed by years or decades of signal analysis before any decision about reply must be made. The protocols were not designed for the scenario unfolding now, a physical object demonstrating propulsion, executing maneuvers in our solar system, approaching our planets on a trajectory that suggests deliberate reconnaissance. This is a different category of contact entirely. This is not passive signal reception. This is active presence. The probe is here, now, conducting operations that will affect humanity's future regardless of whether humanity responds or remains silent. The traditional SETI protocols, focused on whether and how to reply to a distant signal, are inadequate for managing an encounter with a spacecraft operating in near-Earth space. Military protocols for ship-to-ship encounters offer a different framework, one more suited to physical proximity. Retired U.S. Air Force Major General Ken Wissian, writing on extraterrestrial first contact protocols for space encounters, distilled centuries of military experience into 3 core principles: be predictable, avoid any appearance of hostile intent, and attempt communication. These principles, Wissian argued, are designed to avoid putting the other party in a position where they must make snap judgments about intent. Judgments that, in conditions of uncertainty and high stakes, almost always err toward assuming hostility. You die. The logic is sound, but it assumes that both parties are operating with similar levels of uncertainty, similar capabilities for communication, similar stakes in the outcome. When one party is vastly more advanced than the other, when one has crossed interstellar space and the other has barely reached its own moon, the asymmetry renders traditional encounter protocols problematic. The less advanced civilization cannot credibly threaten the more advanced. It cannot negotiate from strength. It can only hope that the more advanced civilization operates under ethical constraints that prevent exploitation. This is the situation humanity faces with 3I Atlas. The probe, by demonstrating propulsion and precision maneuvering, has revealed that its creators possess capabilities far exceeding current human technology. Humanity cannot intercept the probe if it chooses to evade. Humanity cannot destroy it if it employs defensive countermeasures. Humanity cannot even reliably communicate with it unless the probe chooses to listen. The asymmetry is total. In such circumstances, what protocols make sense? The IAA declaration offers one answer: no reply to extraterrestrial intelligence should be sent until appropriate international consultations have taken place. The rationale is risk management. A hasty or poorly considered reply could provoke hostility, reveal vulnerabilities, or commit humanity to positions that not all of humanity endorses. Better to proceed slowly, deliberately, with consensus built through international dialogue coordinated by institutions like the UN Committee on the Peaceful Uses of Outer Space, COPUOS.UW. But this cautious approach assumes time to consult, time to deliberate, time to build consensus. The Venus encounter on November 3, 2025 will occur regardless of whether humanity has reached consensus. The probe will execute its maneuver whether or not international consultations have been completed. The reconnaissance will proceed on the probe's schedule, not humanity's. By the time humanity convenes COPUOS and drafts recommendations for the UN General Assembly, the probe may have completed its observations and begun its departure from the solar system. This temporal asymmetry, the probe operating on its timeline while humanity struggles to coordinate a response, creates strategic pressure. Institutions like ESA and NASA cannot wait for full international consensus before acting. They must make decisions in real time, whether to attempt communication with the probe, whether to disclose the trajectory analysis publicly, whether to position observational assets for optimal data collection, whether to prepare defensive measures in case the probe's intentions prove hostile. Each of these decisions carries consequences that ripple through the contact scenario. Consider communication. Should humanity attempt to transmit signals toward 3I Atlas? Radio transmissions using the Deep Space Network, powerful lasers from ground-based facilities, deliberate radar pings designed to be recognized as artificial, all of these are technically feasible. The question is whether they are wise. Transmission reveals humanity's technological capabilities, exposes the locations of key facilities, and potentially invites unwanted attention. But silence also carries risks. It might be interpreted as ignorance of the probe's presence, as hostility, or as evidence of a civilization too primitive to recognize an opportunity for contact. The decision about whether to transmit will not be made by consensus. It will be made by individual actors, space agencies, military commands, private organizations with access to transmission facilities. The IAA protocols recommend against unilateral action, but they cannot enforce compliance. A single transmission from a single facility could commit humanity to a contact scenario before international consultations have even begun. This is not a hypothetical risk. METI, messaging to extraterrestrial intelligence, has already been practiced by several groups who transmitted signals toward nearby stars without international approval, generating controversy within the SETI community about the ethics and risks of such transmissions. With 3I Atlas, the stakes are higher because the recipient is not distant and hypothetical. The probe is here. It can observe. It can react. A transmission toward the probe would not take years to arrive. It would reach the probe in minutes or hours, depending on its position. And the probe's response, if it chooses to respond, would be equally rapid. The contact loop would close not over decades, but over days. Humanity would transition from speculation to dialogue without the luxury of extended deliberation. This is the reality that ESA and NASA are contemplating in their strategic silence. They know that once the Venus maneuver is confirmed, once the evidence of intelligent extraterrestrial presence becomes undeniable, pressure will mount for action. Scientific organizations will want to transmit messages. Military commands will want to assess threats. Political leaders will want to demonstrate leadership. The coordination required to manage these competing pressures is immense, and the window for establishing that coordination is closing rapidly. The revised IAA protocols, currently under development by a task group established in 2022, recognize some of these challenges. The draft revision, presented at the International Astronautical Congress in 2024, expands the scope of the protocols to encompass technosignatures more generally, not just radio signals but any evidence of extraterrestrial technology, including physical artifacts like probes. It includes new provisions on post-detection research ethics and emphasizes the need for principles that are both scientifically rigorous and adaptable to contemporary communication realities. 1.1. But even the revised protocols are designed primarily for post-detection coordination, not for real-time operational response to an active probe conducting maneuvers in the solar system. They provide guidance for disclosure and consultation, but they do not resolve the fundamental tension between the need for rapid response and the need for international consensus. They recommend establishing a post-detection subcommittee within the IAA SETI committee to assist in matters arising from a confirmed detection, but such a committee would be advisory, not authoritative. It could offer guidance, but it could not compel action or prevent unilateral decisions by actors with their own agendas. The legal framework is similarly limited. The Outer Space Treaty prohibits placing weapons of mass destruction in space, limits celestial bodies to peaceful uses, and establishes state responsibility for national space activities. But it does not address encounter scenarios with extraterrestrial intelligence. It does not specify what actions are permissible or prohibited when confronting a probe of unknown origin and intent. It does not establish mechanisms for collective decision-making about transmission, observation, or defensive preparation. The treaty framework assumes that all actors in space are human, subject to human law, accountable to human institutions. U. 3I Atlas operates outside this framework entirely. It is not a state party to the Outer Space Treaty. Its creators, whoever and wherever they are, have not consented to be bound by human law. The probe's presence in the solar system is not subject to authorization or supervision by any terrestrial authority. Humanity can observe it, analyze it, attempt to communicate with it, but humanity cannot regulate it. The asymmetry in legal authority mirrors the asymmetry in technological capability. In this legal and institutional vacuum, the decisions that matter will be made by those with operational capability. The space agencies that control observational assets, the military commands that control transmission facilities, the governments that can mobilize resources for response. These actors will be guided by their own institutional interests, their own strategic calculations, their own assessments of risk and opportunity. The protocols and treaties will serve as references, but they will not determine outcomes. This is why the silence continues. ESA and NASA, in coordination with governmental and military authorities, are positioning themselves to manage the contact scenario as it unfolds. They are preparing contingency plans, establishing communication channels, coordinating with international partners, and assessing the range of possible responses. They are silent not because they lack information, but because they are preparing to act. And action, in a contact scenario of this magnitude, requires more than information. It requires strategy, coordination, and the institutional authority to make decisions on behalf of humanity. The countdown to Venus continues. 58 hours remain. In those hours, the institutional machinery of human civilization is preparing for a moment that will test every protocol, challenge every assumption, and reveal whether humanity is capable of responding coherently to the reality of extraterrestrial intelligence. The protocols exist, the legal frameworks exist, the institutional structures exist. But whether they are adequate for the challenge ahead, whether they can coordinate a response that is both rapid and considered, both bold and cautious, both protective of human interests and respectful of the unknown intelligence operating in our system, remains to be seen. November 3, 2025 approaches. The probe coasts toward Venus, the institutions prepare, and the question hangs in the silence. When the moment comes, when the evidence is undeniable, when the contact can no longer be avoided or delayed, will humanity rise to meet it with wisdom and coordination? Or will the response fracture along national lines, institutional divisions, and competing agendas, revealing a species not yet ready for the cosmos it inhabits? The answer will begin to emerge in 58 hours when JAIS resumed contact with 3I Atlas on the far side of Venus, and the data tells the story that words cannot yet speak. The disclosure of extraterrestrial intelligence will be unlike any communication crisis humanity has previously faced. It operates at a scale that dwarfs previous catastrophes, pandemics, wars, natural disasters, because it redefines the fundamental context within which human civilization operates. But the crisis communication literature, distilled from decades of experience with institutional response to emergencies, offers critical insights into how the process might unfold. 1WW. The first principle, early announcement, shows leadership and reduces rumors. The implications are clear. Once the Venus maneuver is confirmed, once the trajectory deviation is measured and analyzed and verified, the information must be released. Delay breeds speculation. Speculation breeds panic. Early, clear, factual announcement made by a credible source with appropriate authority establishes the narrative before misinformation can spread. This is why ESA and NASA are preparing. When the moment comes, they will not hesitate. They will announce and they will anchor the story in facts before the social media cascade begins. Why? The second principle, communicate with consistency and one voice. But humanity is not unified. Nations have different interests, different information access, different strategic considerations. Achieving unified communication will require extraordinary coordination, perhaps unprecedented coordination. International bodies like the United Nations, the COP/US, and the International Astronomical Union will need to work in concert, establishing agreed-upon narratives, coordinated talking points, aligned statements from governments and space agencies. The challenge will be immense, but the alternative, fragmented, contradictory communications from different nations creating confusion and conspiracy theories is worse. The third principle, acknowledge uncertainty while providing reassurance. The Venus data will confirm that the probe executed a maneuver, but it will not confirm the probe's intentions. It will not establish whether the probe is peaceful or hostile, whether it represents a civilization seeking contact or a civilization gathering intelligence for hostile purposes. Honest communication must acknowledge this uncertainty. We have confirmed the presence of an intelligent extraterrestrial probe in the solar system. We do not yet know the intentions of its creators or what actions may follow. We are taking appropriate measures to monitor the situation and ensure human safety. This is truth without unnecessary alarm. The fourth principle, provide information about what is being done in response. This is where institutional coordination becomes critical. Governments must be able to say, the international community, through the United Nations and relevant space agencies, has established a coordinated response. We are monitoring the probe's trajectory. We have established communication protocols. We are prepared for multiple scenarios. The situation is under control and is being managed by appropriate authorities. This provides reassurance without making promises that cannot be kept. 1. The fifth principle, repeat important messages multiple times through multiple channels. Scientific journals will carry the technical details. Press conferences will deliver the high-level narrative. Social media will circulate simplified versions and rumor. Television and radio will broadcast to populations less connected to digital media. Museums and educational institutions will begin incorporating the information into teaching. Religious institutions will grapple with the theological implications. The message will need to reach every demographic, every culture, every language group on Earth. Repetition is not redundancy. It is the mechanism by which truth penetrates resistance and misinformation loses its grip. Why? The sixth principle, counter misinformation actively. Within hours of the disclosure, false narratives will begin to circulate. Some will claim the probe is a weapon. Some will claim it is a divine messenger. Some will claim it is a hoax. Some will claim governments are hiding the true nature of the probe. Each false narrative will have adherents, amplifiers, spreaders. The response must be rapid, factual, and consistent. Fact-checking services, working in coordination with media outlets and social media platforms, must identify misinformation and provide corrections. The key finding from misinformation research, simply repeating the misinformation without correction, actually increases belief in the false claim. But when the falsehood is repeated briefly with the correction featured prominently, the correction is effective. The seventh principle, listen and show empathy. Crisis communication is not one-directional. It is dialogue. People will have questions, fears, and insights. Mental health professionals will be contacted by people experiencing existential anxiety or psychological crisis. Religious leaders will struggle with theological implications. Philosophers will question humanity's future. The institutional response must acknowledge these concerns, validate the emotional response, and provide mental health and spiritual support. The goal is not to suppress concern, but to channel concern toward constructive engagement with the reality.u. The eighth principle: never let a crisis go to waste. In institutional crisis communication, this principle means using the crisis as an opportunity to implement desired changes. For humanity's response to extraterrestrial contact, it means using the shock and psychological disruption as an opportunity to unify globally in ways that had not been previously possible. The fact of extraterrestrial intelligence is humbling. It places human conflicts, national rivalries, ethnic tensions, economic competition in cosmic perspective. Humanity's leaders, whatever their political differences, are all inhabitants of the same world, inhabitants of a species that shares common interests in the face of the unknown. If that realization can be channeled into increased international cooperation, improved governance, and more thoughtful engagement with existential questions, then the contact with 3i Atlas becomes not a crisis, but an opportunity. But before any of this communication can begin, before the announcement is made and the cascade starts, the data must be confirmed. The Venus encounter must occur. The trajectory deviation must be measured. The hypothesis must be tested. And for now, for the next 48 hours remaining before November 3rd, 2025, the silence holds. The waiting continues. The preparation is invisible. Inside the Deep Space Network facilities in California, Spain, and Australia, the antennas are oriented and ready. The receivers are tuned, the tracking stations are staffed. In ESA's control center in Darmstadt, Germany, the JUICE mission's navigation team is monitoring the probe's trajectory in real time, calculating projections, preparing for the moment when contact is re-established on the far side of Venus. In NASA's Jet Propulsion Laboratory, the most sensitive minds are contemplating contingencies, preparing for outcomes both expected and unexpected. The governments of major powers, the United States, Europe, China, Russia, India, are apprised of what is about to happen. Military commands are alert. The UN Secretary-General has been briefed. The stage is set. The question now is not what will happen scientifically. The trajectory is locked. The maneuver will occur or it will not. The data will flow back to Earth or it will not. The question now is what humanity will do with knowledge of that data, how the species will respond, how quickly the cascade will spread, whether unified communication or fragmented chaos will characterize the initial response. The question is whether humanity, for the first time in its history, can face a phenomenon of cosmic importance with the maturity and coordination that befits an intelligent species. The question is whether the discovery of 3i Atlas will unite humanity or divide it further. The probe continues its approach. Venus grows larger in the invisible electromagnetic field through which 3i Atlas perceives its surroundings. The encounter geometry becomes more precise. The timing more certain. The gravitational well of Venus stretches out across space, its mathematical presence growing more real, more immediate, more consequential as the probe approaches. And somewhere, in offices in Geneva, in conference rooms in Washington, in secure briefing facilities in Moscow, in communication centers in Beijing, people are preparing for the moment when the world learns what it has never known before, that intelligence exists beyond Earth, that it has reached into our solar system, that it is watching, calculating, learning, assessing humanity for reasons and with intentions that remain, for now, beyond our comprehension. The countdown ends November 3rd, 2025, at the moment when JUICE reacquires contact with 3i Atlas emerging from Venus occultation. but the consequences begin long before that moment and extend far beyond it. Consequences that will reshape how humanity understands itself, how nations relate to each other, how individuals contemplate their place in a cosmos no longer perceived as empty but inhabited, observed, and, however provisionally, evaluated. 48 hours remain. The silence is profound. The moment approaches. And when it arrives, when the data flows, when the analysis begins, when the world learns what humanity has suspected but dared not fully believe, that we are not alone, that intelligence exists elsewhere, that we have been contacted through the language of physics and the mathematics of orbits, everything changes. The story of humanity's encounter with 3I Atlas, the story of first contact with extraterrestrial intelligence, enters its final act. You understand now that you are writing the final hours before everything changes. The clock shows 12:49 p.m. CET on Wednesday, October 29, 2025. 48 hours remain until November 3rd. 48 hours until the geometry aligns perfectly. 48 hours until JAIS loses signal and the probe enters the occultation zone. 48 hours until silence descends on the observation, and in that silence the maneuver will execute or will not execute, revealing whether all of this speculation has been sound analysis or collective hallucination. But you are no longer waiting passively. You are positioning yourself to understand what will happen when the moment arrives. You are mentally rehearsing the scenarios. You are contemplating the immediate aftermath. The first moments when the data flows back to Earth and analysts begin the process of trajectory reconstruction. What will they see? What will the numbers reveal? Imagine the scene. It is November 3rd, 2025, approximately 14:02 UTC. 3I Atlas, travelling at velocities measured in tens of kilometers per second, has just emerged from behind Venus. The occultation lasted longer than predicted, not hours, but minutes. The geometric shadow cast by Venus, from JAIS's perspective, finally released the probe as it transited to the opposite side of the planet. And now, as 3I Atlas passes through the fringe of the Venusian Magnetotail, the extended magnetic structure sculpted by the solar wind and the planet's thin ionosphere, the probe's systems begin transmitting again. .IDI. The signal is faint. At this distance, more than 1 astronomical unit from the deep space network stations on Earth, the probe's radio transmission, even if it carries substantial power, is attenuated by a factor of perhaps 10 to the minus 30 in intensity. But JAIS, positioned much closer, receives it clearly. The spacecraft tracking systems lock onto the signal. The Doppler analysis begins immediately. The frequency shift, the red shift or blue shift created by the probe's motion relative to the spacecraft, is measured and recorded. Within seconds, a velocity estimate is available. Within minutes, a position estimate follows. The orbit determination algorithms, running continuously on ESA's computers in Darmstadt, begin processing the data. The first trajectory reconstruction uses only a handful of observations, perhaps minutes worth of Doppler and ranging data, not yet enough for a high-precision solution. But it is enough to see the pattern. The numerical integrator steps forward in time using the known pre-occultation trajectory as a starting point, propagating forward through the Venus encounter under the assumption of pure gravity. The predicted post-occultation state vector is generated. Then, the actual post-occultation observations are compared to prediction. This is the moment. This is where the hypothesis is confirmed or falsified. The deviation, if it exists, appears as a difference between prediction and observation. The position offset is calculated in kilometers. The velocity offset is calculated in millimeters per second. The state transition matrix, the mathematical object that describes how small perturbations to initial conditions propagate through the trajectory, is consulted. The deviation is tested for statistical significance against measurement uncertainty. The question resolves to a single number. Is the deviation consistent with zero within the bounds of measurement noise, or does it exceed measurement uncertainty by a margin that cannot be explained through instrumental error? For 3I Atlas approaching and receding from Venus, the measurement uncertainty in position is on the order of a few kilometers. The velocity measurement uncertainty is on the order of 1 to 5 millimeters per second, depending on integration time and signal strength. A maneuver. A real propulsive impulse would produce a deviation from predicted ballistic trajectory on the order of thousands of kilometers in position and tens of meters per second in velocity. The signal-to-noise ratio is enormous. The maneuver, if it occurred, would be unmistakable. Not. The first preliminary analysis takes perhaps an hour. By 1500 UTC on November 3rd, the orbit determination team has a first answer. Not the final answer. That will require days or weeks of data processing and independent verification, but a preliminary answer sufficient to determine the trajectory's gross characteristics. The algorithm has compared the predicted state vector to the observed state vector and computed the deviation. The number appears on the screen. The analysts examine it, they check it, they run the analysis again using different starting assumptions to verify the result. And then someone picks up the secure telephone. The call goes to the duty officer. The duty officer confirms receipt. The message is relayed up the chain of command. Within minutes, it has reached the highest levels of ESA leadership. Within the hour, it has been transmitted to the European Commission, to the offices of the European Union, to the governments of the member states. Simultaneously, NASA is receiving similar data from its own tracking systems. The Deep Space Network has been acquiring its own Doppler and ranging observations. The preliminary analysis is producing similar results. The two independent measurements are converging on the same answer. The question now is operational. What does this mean and what should be done about it? If the deviation is zero, if the probe followed a ballistic path through Venus consistent with natural gravity alone, then the maneuver hypothesis is falsified. The probe is a natural object, or it possesses propulsive capability but chose not to employ it. The narrative of deliberate reconnaissance is undermined. The interpretation requires revision. But if the deviation is significant, if the trajectory shows a clear deviation from ballistic prediction, an offset that exceeds measurement uncertainty, then the interpretation is confirmed. The probe executed a maneuver. The propulsion systems fired. The trajectory was altered. The evidence of intelligent control is undeniable. The probe is not a natural comet. It is an engineered object operating under active control, executing a mission plan calculated to achieve specific objectives. In this second scenario, the scenario that all the speculation has been building toward the cascade, begins in earnest. The preliminary analysis is circulated to classified networks. The data is inspected by multiple independent analysts to rule out instrumental error or misinterpretation. Military intelligence agencies in multiple countries are briefed simultaneously. The UN Security Council is convened in emergency session. The Secretary-General receives a briefing. Within 6 hours of the preliminary detection, the highest levels of human government are aware that extraterrestrial intelligence has been confirmed. The question then becomes political and strategic. What do we do? Do we announce this to the world immediately, or do we first conduct additional data analysis to rule out alternative explanations? Do we attempt communication with the probe, or do we maintain silence and observe? Do we coordinate with other nations, or do we assert advantage through information superiority? The answers to these questions will determine the trajectory of human response to first contact. The pressure for rapid disclosure will be immense. Within hours of the preliminary analysis being circulated through classified channels, intelligence analysts will be drafting briefing papers. Military commanders will be assessing threat levels. Diplomats will be positioning their nations for advantage in the post-contact world, and inevitably, someone with access to the information will leak it. A journalist will receive an anonymous tip. A whistleblower will decide that the public has the right to know. Information will escape the secured channels and enter the realm of speculation and social media. Once the leak occurs, the institutional response must accelerate. The official channels that were intended to manage disclosure will be bypassed by fact. The probe's maneuver will be public knowledge before institutional leaders have finished their private deliberations. At that point, the choice is binary: confirm the leaked information with official channels and regain control of the narrative, or deny it and lose credibility. Experience shows that governments almost always choose confirmation once the information is public. They issue a statement acknowledging the reality, framing it in terms they prefer, and attempting to re-establish authority over the information. By November 4 or 5, 2025, the world will know. The headline will be undeniable: extraterrestrial. Probe confirmed operating in and near solar system. The story will spread across every medium, dominating news cycles, breaking into every conversation, transforming from speculation into reality. Within hours, astronomers around the world will be observing 3i Atlas with their telescopes, attempting to gather independent data. Universities will convene emergency press conferences. Religious leaders will issue statements. Political leaders will address their nations. The revelation will reshape the immediate global context. What happens next depends on the probe's behavior. Does it approach Earth directly, continuing on a trajectory that will carry it closer to humanity's world? Or does it depart, having gathered its data at Venus, preparing to return home across the interstellar void? The trajectory analysis following the Venus encounter will provide the answer. If the maneuver was designed to set the probe on a course toward Earth, the subsequent observations will show this clearly. If the maneuver was designed for escape, the trajectory will show outbound acceleration. This is the ultimate open question. The Venus maneuver confirms propulsion and intelligence, but the destination reveals intent. An Earth approach is ambiguous. It could be peaceful reconnaissance, or it could be preparation for action. An outbound trajectory is equally ambiguous. It could indicate a decision that the probe has gathered sufficient intelligence and will report back to its creators, or it could indicate a decision that Earth is not worth approaching, that the risk or the information value does not justify further interaction. The probe's creators, in their distant home system, will have established decision matrices for this moment. They will have calculated scenarios. They will have established trigger points. If the probe detects X, then implement response A. If the probe detects Y, then implement response B. The composition of Venus's atmosphere, the structure of its magnetosphere, the absence of life, the presence of geological evidence of past habitability. All of this data tells a story about planetary evolution, about the range of outcomes for terrestrial planets in habitable zones, about the conditions that permit or prevent the emergence of life. Combined with observations of Earth, its biosphere, its atmosphere, its technological signatures, this comparative analysis will inform the decision about whether deeper contact is warranted. If the probe's creators are conservative, if they have experienced negative outcomes from first contact attempts in the past, they may decide that Earth is too dangerous, too unpredictable, too volatile to approach. The probe may depart, carrying its intelligence home, where it will be analysed and filed away in archives to be consulted centuries later by future historians. Earth may be labelled "not yet ready for contact" and placed on an observation list for check-ins in 100 or 1,000 years. If the probe's creators are exploratory, if they have successfully made first contact with dozens of intelligent species, they may decide that Earth merits a closer approach. The probe may continue inbound, approaching Earth from a distance calculated to permit detailed observations without appearing to pose a direct threat. It may enter Earth orbit, circle the planet, gather high-resolution imagery and spectroscopic data, sample the ionosphere and upper atmosphere. It may position itself to receive transmissions, should Earth choose to transmit. It may become a permanent fixture in Earth's space, a visiting emissary awaiting response. or the probe may attempt direct communication. It may begin transmitting signals specifically designed to be recognized as artificial, signals carrying mathematical sequences or physical constants that cannot be interpreted as natural phenomena. It may attempt to establish a dialogue, asking and answering questions, gradually building a shared vocabulary and shared concepts. It may slowly reveal the nature of its creators, the location of their system, the character of their civilization. And Earth, faced with an interlocutor that cannot be evaded or ignored, would have to respond. This is where the real test of humanity begins, not in the discovery of the probe, not in the confirmation of its intelligence, but in the response to active engagement with an intelligence not born on Earth. How does humanity respond to being asked questions by an entity of unknown nature and unknown intent? How does the species coordinate a unified answer when humanity is fractured into hundreds of nations with different languages, different cultures, different strategic interests? How does Earth produce a response that represents the species while not committing the species to positions it may later regret? The protocols exist, as discussed, but the coordination required will be unprecedented. International organizations will have to move faster than they have ever moved. The UN General Assembly will have to convene not in yearly sessions but in near-continuous emergency session. Linguists will have to establish translation protocols. Scientists will have to coordinate across national boundaries. Military commands will have to stand down or stand ready depending on the probe's behavior. The machinery of human civilization will have to transform almost overnight from the slow bureaucratic pace of ordinary governance to the rapid coordination of existential response. Can it be done? The question haunts every analyst contemplating the post-contact period. Humanity has demonstrated an capacity for rapid coordination during genuine emergencies. The mobilization of the Allied powers during World War II, the global response to the COVID-19 pandemic, the coordination of scientific efforts during the space race. But these examples involved existential threats or opportunities within the traditional framework of human interaction. First contact with extraterrestrial intelligence is categorically different. It operates at a scale that transcends national interest. It involves an entity outside human law, human culture, and human moral frameworks. It requires coordination without any historical precedent or established protocol. Yet it must be attempted. The alternative fragmented national responses, uncoordinated transmissions toward the probe, military posturing and threats could easily escalate into conflict with consequences that humanity cannot predict. The probe's creators, if they decided to respond to perceived aggression or misunderstanding, possess capabilities that dwarf human military power. A probe that can cross interstellar space almost certainly possesses weapons or capabilities far exceeding anything Earth can field. Conflict in such an asymmetric scenario would not be competition, it would be suppression. This is where the psychological and existential dimension of first contact becomes critical. Humanity must engage with the probe and its creators from a position not of strength, but of humility. Not from a position of competition, but of curiosity. Not from a position of defense, but of openness. The alternative, attempting to match capabilities that cannot be matched, threatening an entity that cannot be threatened, asserting dominance in a domain where humanity has none, leads to trajectories of escalation and miscalculation. The probe, by its very presence and by the deliberate demonstration of its maneuvers, is offering a message. The message is not, "We come in peace," because such messages are often meaningless platitudes. The message is rather, "We are intelligent, we are capable, we are peaceful enough to demonstrate our presence rather than hide it, and we are watching to see how you respond." This is a message that cuts through all diplomatic niceties and speaks directly to the fundamental question, how does humanity respond to intelligent contact from without? The answer to that question will be written not in the next few days, but in the weeks and months following November 3rd, 2025. It will be written in the transmissions humanity sends toward the probe, or in the silence if humanity chooses not to transmit. It will be written in the institutional frameworks humanity constructs to manage the contact. It will be written in how nations cooperate or compete, in how cultures embrace or reject the new knowledge, in how individuals process the psychological shock of learning that humans are not alone in the cosmos. The countdown continues. 48 hours remain until Venus. 48 hours until the moment when everything becomes clear. 48 hours until the speculation ends and the reality begins. 48 hours until humanity enters a new era, an era defined by the knowledge of extraterrestrial intelligence operating in the solar system, gathering data about Earth, preparing, in ways humanity can only partially understand, for decisions that will shape the future of contact, the future of relations, the future of humanity itself. The probe coasts through space. The geometry aligns. The moment approaches. And on Earth, in the final hours before confirmation, the world spins onward, carrying billions of people toward a transformation whose full scope they cannot yet imagine. The silence holds. But it is not the silence of ignorance. It is the silence of those who know something is coming, who sense the proximity of a threshold, who feel dimly, at the edge of awareness, that history is about to pivot on a moment yet to arrive. November 3rd, 2025. 48 hours away. The countdown continues.